my co-chairs, Rachel Christensen and Damon McCoy. My name is Carmela Troncoso, and it's an honor for me to be presenting Starting Pets at the place where I can call home. Because when you're American, this happens very often. When you're European, it doesn't happen that often, and I felt very lucky that I can be in my country introducing this. So, I don't know for Rachel and Damon, but to me, this felt like this. Okay, so we were playing this game. The first level, it was kind of easy. We had 40 submissions, 7 accepted, kind of a good thing. Second one was 39 submissions, 7 accepted. The third level started to be difficult. We actually got 62 submissions, from which we accepted 10. And in the last level was the most difficult one, 77 submissions, 12 accepted, but at the end, we reached the goal and we're here in Barcelona today. But of course, we did not do this alone. Actually, the chairs just are here as masters of ceremony. We actually had 663 authors that submitted no less than 218 papers, which in total amounted to more than 3,500 pages. And if you want to get a sense of what this is, if you take A4 and you take the long side, this is like more than a kilometer for the Americans, more than 300 and 500 feet. And then, if you also want to get a sense of this, this is like 11.5 times the height of the Statue of Liberty, 3 times the Eiffel Tower, and even 1.3 times the biggest building in the world, which is in Dubai, and I could not remember this name, even though I tried again and again. Because I'm not Ian Goldberg. You know, that now is also the most said term at Pets. So, because pages, this A4 letter, I know it is difficult, so another sense of getting the volume of this is that these were more than 700,000 words. And again, if you're gonna get a sense out of this, this is like about a half of all of the series of Harry Potter, almost one Bible, 1.2 for War and Peace, and like 2 times like the longest book that we have in Spain, which is the Quixote. Okay, but of course, like authors in and on itself, they don't make a conference. We also have 102 reviewers and 137 external reviewers that volunteer themselves to suffer through a paper again and again. And they produce 829 reviews and 6,000, more than 6,000 comments. And this is actually almost 2 million words, like 2.5 times what the authors wrote. Which means that actually we would have written like twice Harry Potter. And if instead of doing something like science, we would be doing something serious, probably we would have finished Game of Thrones by now. And all of this turned out to be a wonderful program. We have 3 days full of sessions about different topics related to privacy. I want to call your attention to Friday. On Friday, the schedule changes a little bit because we have Thursday, sorry. On Thursday, the schedule changes a little bit, so don't miss your lunch, and in particular, the sessions after lunch are a bit different. For each of these sessions, we have a session chair. Please, session chairs, stand up. Authors of these sessions, please try to find your session chair before starting, and make sure that your laptop works, that you know how they are going to run the session, etc., etc. Another thing new for these pets that we're going to have a streaming, and we're going to allow for remote questions. Last time in Minnesota, we tried this thing for a closed set of people. This year, we have everyone can join. This is the link. Can everybody see the link? Otherwise, can't you see the website? The link for the streaming?
Yes.
Okay, so just check on the website. There is it's on Twitter as well. Everything is on Twitter as well. So just go there, there is a chat, and we have here streaming chairs. There are persons that we're thankful very much because they volunteer to just take a look at the chat and relate the questions to the speakers. All of these questions are going to be there. Questions do not disappear. So speakers, after your talks, you can go back if you want and see what people commented, and if there is any question left, feel free to address them. Another highlight of the program, today we have a keynote. We have Alan Misloff talking about targeted advertising and how this relates to privacy and the opportunities it opens for us. Super cool talk, don't miss it. Tomorrow we have our traditional town hall where we will present to you the state of pets. This will be run by the co-chairs, Damon, Rachel, and myself. And we will also have the 2019 chair, Costas. Is Costas around? Costas is not around. So please prepare your questions and comments. If you have doubts before, come to us. We're happy to receive your feedback. We're happy to try to improve. So please help us. On Thursday, we have the ramp session, as always, traditionally run by Roger. Please, Roger. So if you want to talk about something you want to present, these are 5-minute talks. Just talk to Roger, and he will make sure this happens. We also have the Andreas Fishman Best Paper Student Award. Paul here has agreed to be the chair for this year. This is an award that we give to papers primarily written by a student who is presented the work at PETS. So for PC members, you have received an email about this. Make sure you read it. For non-PC members, we also value your opinion. If you have any feedback, you see any paper that really deserves the award, please go to Paul and give them your feedback. And there are many more people that actually made this happen. It's not only the chairs, not only the authors. There is a bunch of people needed in order for us to come here. We have the publicity and web chairs, Kat Han and Baudo Lux, that had made an humongous work on going on Twitter and also on the kind of being always there every 5 minutes. We want to make a change on the program or a change on the committee. We have our hot prep god, Ian Goldberg, that anything we ask from him, he's crazy enough to make it happen. Sponsor chair, Stephen Murdoch, who made sure that we got a bunch of money from different people to help a lot of you to come here. Publications chair, Mark Quarret and Philip Winter. The video chair, Aaron Johnson and Ryan Henry. Stipend chairs that made sure that this money was allocated correctly. The PET Award chairs, Matt Wright and Ahmad Hera, and the Hotbeds chairs that prepared a wonderful program for Friday, Tariq Elahi and Susan McGregor. A big applause to them all, please. And I also want to mention an honorific role for this year. Ian Goldberg is Time Zone chair. He made sure that every single issue, he would send an email to me saying you have the deadline wrong in the Hot Crap website. He had not been there, you guys couldn't submit. And also super important, the team here at Barcelona, our general chair, Gemma, please stand up, and also the wonderful people. Griselda, Erica, and Gabrielle that are around here. They are the ones that, again, fix everything like Wi-Fi, laptops, all of the things that you think they run smoothly. It's only because they are here working day and night. If you need help, they have special badges. Instead of have a horizontal one that is blue, they have a vertical one that is red. That's how you can recognize them, and they will be happy to help you at any time. A bit more of logistics. For coffee breaks, we would go, in the end we start here. Okay, so we don't go downstairs, we will stay here. If you were here yesterday, you can also go back through the back of the room. So just please spread, because we're many more people than yesterday, so that we have a space and we don't die of heat. Restrooms, they are in the same floor. For the lunches, we're gonna go down, you're gonna cross the street, just cross, this is this building from the University of Barcelona, it's the Faculty of Geography. In the -1 to the right, you have the restaurant, and you should have your tickets, okay? They should have given them to you in registration, 1 ticket per lunch. And Barcelona is known for pickpocketing, so please watch your belongings when you're here, when you're there, just make sure you don't lose anything. For our social evenings, tomorrow Wednesday we have a banquet in Brasserie Flo. It's about 30 minutes walk from here from the venue. Just check your Google Maps. And on the 26th we have a PET Award reception, nicely sponsored by the Code at the Ayuntament of Barcelona, that will be in the Ateneo Barcelonès, super nice garden. And for the rest of your evenings, organization has been nice enough to just have a page where you have a lot of bars and other things to do. For the hike, okay, the hike was a bit controversial. So we said 7:30 in the program. This is a lie. In the end, we're gonna start at 9. We're gonna meet you all in Plaza Catalunya, in front of the Hard Rock Cafe. And when I say 9, I mean 9. Everybody that is not a 9 on the bus will not be on the hike, or will not be on the hike with us. And the people that know me know that this is true. So we will go then on the bus, 1 hour and 15 or something like that, so the people that can go out on Friday can sleep 1 hour more while they are on the bus. And then we will do a route. It was also pointed out that this route may be too brutal for some people, because we said 4 hours. So we're glad to say that you can also choose a 2-hour option. You can walk half of the route and then take a cable car down for €7. Or you can also try to meet us in the middle, like go later on your train to Montserrat, take a cable car up, and you can meet the rest of the group when they are halfway through the hike. In these instructions that you were given, it looks like the hike is this scary thing. We're gonna climb the Mount Everest and you need all of your gear. This is a lie. It's a normal hike. Just come. This is gonna be fine. You don't need super special stuff to go there. Bring water. It is super hot. Yeah, and then the organization also provides meals, little bag. Now, if you come halfway, if you use the option of the cable car, then we're not gonna carry your food actually all the way. So please bring your own food. Once we get to the end of the hike, you can either choose to visit Benedictine Abbey, that is there, or just directly take the train back to Barcelona. Take into account that all of the rest is covered by your registration, not the train back. And now it's very important for all of these logistics to know how many people go in the bus, how many people not, that you follow the algorithm. If you subscribed when you clicked, okay, still make sure that the organization knows whether you're coming or not. And if you did not subscribe, you also need to go. Again, not in the list, not in the bus, not in the hike. And no food for you. As discussed in the last town hall, we actually have introduced a code of conduct. We want pets to be a safe space where everybody is treated with respect. If you feel that something is not going how you feel like, please contact our contact persons, Paul and Griselda there. Just please go to them. You also have an email if you prefer, safespacepets@petsymposium.org, and just tell us what things you're feeling that are going well, and we will try to fix it. So just to finish, I would like for the people that, they don't have a paper and they say, why I don't have a paper, some tips to have a paper. So I made a small analysis, super analytic analysis, which is a cloud of words, of the papers that were accepted. And apparently if you write papers about privacy and users and do some attacks on data, you get your paper accepted. But then I was very troubled because you write a paper about users and privacy on data, you get your paper rejected. So I didn't know how to solve this thing, and when you don't know, and then I decided to do what people do when they don't know how to solve the problem, which is machine learning. And then I was like, oh, so which machine learning should I use? This random forest, this SVM, I don't really know. So I asked, what would Nikita do? Go to Twitter. I went to Twitter and tried to find the solution, and then I found, okay, what is machine learning? But this thing said the statistics, and it says the statistics, so it didn't really look like machine learning. So I went again and searched again, and this is like, okay, machine learning is this hacky thing where you just go around and say, okay, I actually know how to do this. Like I spent all my undergrad actually doing machine learning. So that's what I did. I made a list of words at random. I tried to just make words in and out of this cloud of words. And actually, well, by the way, nobody gave me more money to do this machine learning. So actually, this is what will get your paper in. So have papers about apps and tracking, and a lot about clients and systems, a bit of Tor there on the corner. And if you really want to be rejected, just write a paper with results that have model about a mechanism, and then you're off. So just to finish, thanks to our sponsors, thanks to the Ford Foundation and NSF that give a lot of money for our stipends, Zcash, Google, Brave, Comcast, Orange, and the Ayuntamiento of Barcelona that make sure that we have all of these nice spaces to hold the conference. And I have run out of important things to say, non-important things to say, and people to stand up. So let the show go on. Today we don't have Harry. Whenever you hear the thing, just come back to the room.
Does this work? Yes, okay. All right, everybody. I'm going to raise the bell. All right, for the first and lovely session, I'm going to be playing the role of Gunesh. And we have a lovely paper on No More Ads by Anastasia Shuba from UC Irvine. And I'm going to let her get started.
Hello? Hello? Is it working? Yes. Okay, so thank you for the introduction. My name is Anastasia Shuba. Closer? Okay. My name is Anastasia Shuba, and I'll be presenting No More Ads to you, which is a system for effective and efficient cross-app mobile ad blocking. And this is joint work with my advisor, Athena Morkapoulou, and Zubair Shafik from University of Iowa. So, I'm sure this has happened to all of us, where we're trying to browse some news, or we're trying to play a game and an ad pops up and distracts us from what we're trying to do. Aside from being intrusive, ads also cause you a lot of overhead in terms of network and CPU usage. And on top of that, a lot of ad libraries collect your personally identifiable information, or PII, for tracking and personalization purposes. Finally, some ads have even been shown to spread malware. A little bit more background on ads. The way they work, when you have an app that wants to request an ad, it could be a browser app or it could be a game. It will send an HTTP or HTTPS request to the ad network, and then the ad network will respond with an ad that will pop up on your screen. Now on desktops, ad blocking has been largely explored. I'm sure everybody here has heard of AdBlock Plus, Brave, and uBlock Origin. And the way these ad blockers work is they block URLs within those requests based on some rules that follow a very specific syntax. So here's an example of one such syntax from EasyList. And if you want to create an ad blocking list, you create multiple rules for multiple pages where you want to block ads following this specific syntax. You repeat the procedure for multiple pages, and you end up with some 64,000 rules that are on EasyList. So as you can imagine, this is a very tedious process. You have to make sure that your rule follows the syntax, blocks the ad, but does not break the web page. And if the ecosystem changes, you have to update your rules, make sure they're not redundant, and so on. On the mobile devices side, things are even less explored. So in this slide, I will review the most closely related work. There's more details in the paper about them. So there are some apps, such as DNS66 and Disconnect, that also block ads based on a list. So they're not automated. They just follow a list. And they're actually less fine-grained than EasyList, because EasyList blocks based on URLs. And these lists typically block based on hosts and domain names. And this can actually be a little bit problematic because some domains are multi-purposed, so they might serve ads, but they might also be serving content that is essential for the functionality of the app. And if you block that content, it might break the application. The nice thing about these works, though, is that their lists are often more mobile specific, so the list of hosts and domain names were curated for the mobile device. And because they use a VPN-based solution where they intercept traffic, these apps can block ads across multiple apps, so not just the browser app. However, 86% of ad blocking apps that are out there on the Google Play Store only block ads within the browser app itself. There is an AdBlock Plus version that blocks ads across multiple apps, but it requires either a rooted phone or a complex Wi-Fi proxy setup that is not suitable for the average user. In the literature side, there has been some recent work, for instance at NDSS of this year, that collected a lot of mobile data from many different users, and they looked at the communication graph between apps and domains, and if more than one app contacted the same domain, they labeled it as a potential tracker. And I'm simplifying things a little bit. But in the end, they have a list of domains, so again, this is not as fine-grained and can lead to some broken apps if we use this domain-based list. Slightly different direction here was Recon, where they looked at different packets and they used a classifier to predict whether or not a packet contains a piece of PII, and their solution ran on a VPN server where they applied these classifiers. So in our work, we tried to combine all of these good things, as I will show you in the next slide. So obviously we want to block ads, so we train on some mobile data. We use a machine learning approach where we have a classifier sitting on the device, and given a packet, it predicts to us whether or not it contains an ad request. So that we can block ads across multiple apps, we again use a VPN-based approach that does not require a server. With that come a few efficiency challenges, but luckily there has been a lot of related work that has already been done. So we built on top of AntMonitor to gain that efficiency, and we do a few more tricks to make sure the classifier can also run in real time. So for the rest of this talk, I will go through each component of our system. It consists of roughly 4 components. We have the server that does the training of the classifiers offline. We have the AntMonitor library that runs on the device and intercepts the packets. We have the classifier that predicts based on the packets, as I showed you in the previous slide. And we have a data collection mechanism, because we need some ground truth to train our classifiers. So I will start with the data collection. We started out by testing the top 50 most popular apps, and we started with EasyList as a labeler for our ads, and then we added rules to it to make them more mobile specific. So we interact with the app for 5 minutes. If there's no ads being shown, that means EasyList labeled all the packets correctly. We save the packet traces and their labels and move on to the next app. If we interact with the app and an ad is shown, that means EasyList is not complete, so we try to create a new rule, add it to our list, and then test the app again. From here, a few things can happen. It's possible that the same ad might be shown. That means our rule was wrong. We need to delete it and try again. We interact with the app again. Possible that a different ad might be shown, because apps will keep trying to fetch an ad if the first thing is not working. So we need to create yet another rule. And we can get stuck in this loop for a while, but hopefully eventually there's no more ads, and we can save the packet traces. To summarize our data set, we have 50 apps, about 15,000 packets, 4,500 of which contain ads. And with just these 50 apps, we were able to cover 41 ad libraries. So if I have a graph over here of our data set, on the x-axis we have the ad libraries, and on the y-axis the blue bars show the number of apps in our data set that contain that ad library. And the orange line is the percent of total installs on the Google Play Store that contain this ad library. So as you can see, the ad libraries have a long tail distribution. So to gain a comprehensive view of the ecosystem, we really need to worry about the top 30 or top 40 ad libraries. And in fact, our data set covers all libraries that account for at least 2% of all installs. This is the first mobile ads data set that we're aware of, and we made it available on our website as a contribution to the community. We hope that it will be useful to other researchers. Because if you use EasyList alone, it's not enough for the mobile ads data to collect a good mobile ads data set, as it fails to detect 37% of ad requests. So it can detect ads by popular ad libraries such as AdMob and Mopup, which have desktop counterparts, but fails to detect other popular ad libraries such as Unity Ads and AppsFlyer that are over there. And as you can see, they have actually a lot of installs, so they're quite important. So that concludes our data collection mechanism. Next, I will go through how we train our classifiers. So first, if you look at how popular lists perform on our data set, we see that EasyList has a 77% F1 score, and other mobile lists that are host-based perform even worse. So just to see how our classifiers can perform on a network layer features only, we trained some decision trees using destination IP and port number, and then also the domain. And with just these network layer features, we were able to already gain better performance than the lists, having about 87% F1 score. But then we wanted to see if we can do better by looking deeper into the packet. So for that, we looked to Recon, and we changed it to predict ad requests instead of PII, and made it run on the device instead of a VPN server. So if we look at the packet, it looks something like this. And from this packet, just by looking at it, we can already kind of tell that this is an ad request. It's going to ads.mopup.com, it has this /ad, and it's sending the width and heights of the device so that it can fetch a properly sized ad. So what we did is we break this packet into words based on various delimiters, such as the equal sign, ampersand, or question mark, and we end up with a vector of words. We repeat this procedure for all the packets in our data set, and then we end up with a huge list of words that are the features for our classifiers. So if you look at the decision tree that's trained on the URL, we already have a much better performance, about 93% F1 score. But because now we have this list of words, our number of features goes up to thousands, and now our training time is in orders of minutes instead of milliseconds, which is still fine because it's running offline. And our resultant tree size is still small, 196, which is orders of magnitude less than the lists that have like 64,000 rules. If we add headers to our decision tree, we do even better, and this makes sense because EasyList actually takes on the HTTP referrer header, so it makes sense that it helps in our classification. Because we have more words, again, our training time goes up a little bit because the number of features goes up. Next, we looked at if other contextual information can help us in the classification. For instance, whether or not a packet contains some PII or the application name. And these extra features do help in the classification. Actually, with the app name, we achieve the best performance. But in reality, we might not have the app name when we're trying to predict on an app that was not part of our training set. So the more realistic case is where we use the URL headers and PII classifier. So I will focus on it for the rest of the talk. If you look at our classifier, here's a sort of partial view of it. At the top of the tree, we have the most important feature. In our case, it turned out to be DNT, that do not track. And from there, the tree splits on other words that make intuitive sense, like ads.mopup.com makes sense if a packet contains that, it's labeled as an ad. If we look deeper into the tree, we still have more intuitive features as well. In this case, we have a piece of PII, advertiser ID. So these can actually be helpful to somebody trying to create a list. They can look at the tree for some suggestions on how to create rules. To summarize the training, the more information we use, the better our F1 score, and the classifier of choice, the URL headers and PII, performs quite well. Our code is also available on the website, so you can reproduce our results with our data and the code. The results I showed you earlier were based on cross-validation based on packets, but we also did splitting based on app names. So we split the training and test sets based on the apps, And even in that case, 70% of apps had an F1 score of over 80%. We also looked at how ad libraries fit into the performance and found that even in the cases where the ad library overlap is below 100% between the training and test sets, we can still achieve an F1 score of about 100%. So this concludes the training section. Next, I'll go into how we achieve the real-time machine learning on the device. So the main problem here is we want to avoid this parsing step. We really want to avoid Java, string matching, and regular expressions on the mobile device because we have limited CPU and we want to run in real time. So for that, we looked into our tree for some intuition. We really need to worry about the words that appear in the tree. And again, our tree size is small. So if we just extract these 100 words, we can use very efficient deep packet inspection mechanisms, such as the native C implementation of the AHA-Karasik algorithm that's already provided by Monitor, and it can find multiple words in one pass of the packet in less than 1 millisecond. So now, given a packet, we just look for these words. In this case, we find the DNT and the ads mopup.com, and we pass just these two features to the classifier. The classifier then goes through, says, OK, DNT, ads mopup, and spits out that this is an ad. So this is the first time that we know of that we were able to achieve on-device per-packet classification that can run in real time. We did some evaluation testing and found that we can extract the features and apply the classifier in about 3 milliseconds. And most of the delay comes from the application of the classifier, not the deep packet inspection. We did a few more improvements recently and got an even lower number, about 2 milliseconds per packet. So to conclude, I presented to you NOMA Ads, which is a system for effective and efficient machine learning for ad blocking on the mobile device. And for future direction for Nomads, we are looking to increase our data set by maybe making the process more automated. Right now it's very manual. We're also looking to detect if we're breaking the app by blocking ads. And we are looking into extension to trackers, so not just ads. So thank you very much. And as a reminder, our code and data set is available on our website.
Hello, any questions? Okay, Jeremy?
Thanks, really interesting talk. I enjoyed it. I'm curious what percentage of false positives you're getting and what percentage of false positives do you think is acceptable to a user of a mobile device because it breaks things, or maybe I missed that.
That's a great question. So we actually looked more closely at the apps and the number of false positives that we're getting. I have a backup slide here somewhere. And the number of false positives is quite low. And then we looked at the packets that are generating these false positives, and they still have curious strings like ad format equals video or reward tracker. So these are probably actually OK to block. The app doesn't seem to break still. So maybe it means even our rule set is incomplete and we should be blocking more. Does that answer?
Well, the second part is how much false positives can users tolerate?
So that's where we want to see if we can detect app breakage. So far, we have not seen that the apps break with our classifier. So as long as we're not breaking the app, and even though we're not generating false positives, I think the users can tolerate that.
Like you said in the introduction, one of the problems with the conventional way of blocking ads is to not break functionality. What about the apps that actually require an ad to play to continue? Is there a way to know this beforehand and actually maybe allow these apps to not break functionality?
That's a great question. So far, we haven't seen anything like that. But maybe in the future, as we increase our data set, we will. And in this case, we'll have to tell our classifiers to allow this ad. We can maybe use like static analysis approaches to examine the app code and then see if they're actually requiring the ad to be shown.
Any more questions? I have a quick question, which is, you've been mostly focused on blocking the ads, but you sort of get some tracking protection built in. Did you measure sort of how much of that is true?
How much tracking?
How much protection against tracking you get with this?
We did not measure that. We did not have the tracking list, but that's part of the future work to extend to trackers.
Cool. Ian.
Hi, thanks. When you block So you get the packets one at a time. You're operating in VPN mode. So if you see a packet that has a GET request for an ad, do you just drop it? Do you reset that TCP connection? Do you send back a 404? Like, how do you
Excellent
actually?
question. Yeah, if we just drop it, they will keep trying, right? TCP retransmission, and that will eat up the device. So we found if we just send an HTTP empty response, that seems to shut it up a little bit, and it works.
Okay.
So did you try if this works across different locations or places, or is all of your data set collected locally in the US? Because different places have different ads. Is something, like, what do you think about it?
That's a good point. As we're looking to extend our data set, we're going to try to use like an emulator mode, and then we can fix different locations for it. For now, yes, unfortunately, we've been all done in the US.
Thank you. The list of suspicious strings that you show there and you've shown elsewhere makes it sort of appear that the ads are not doing anything to obfuscate that they are ads. But if a system like this became popular, probably advertisers would react by starting to obfuscate their ads in order to not get blocked. Do you think a system like this has a good chance of surviving that arms race? Or do you think you'd need to proceed in a different direction entirely?
That's a great question. That's some of the reviewers' comments. So people that have been blocking PII, personally identifiable information leaking out the device, have also looked if apps obfuscate the fact that they're leaking these strings. And so far, obfuscation has been quite minimal. So we're hoping the same will be with the ads. But even if they obfuscate, we can keep retraining the classifiers. This is the nice thing about having a machine learning approach.
Okay. Thank you. Okay, next we have Ahmad Bashir from Northeastern, and he's going to talk a little bit more about tracking and such things.
Good morning, everyone. Everyone can hear me? All right. My name is Ahmed, and today I will tell you about how user tracking data moves in the online advertising ecosystem. This work is done with my advisor, Krista Wilson at Northeastern University. So let's get into it. We know that when a user goes online and starts browsing the web, this information is known by multiple third parties. For example, in the case of CNN, there could be third parties such as DoubleClick and Facebook present on the website, which sees that information. And as the user browses more websites, it essentially exposes itself to more and more third-party trackers. But we know this. We can actually visualize this information in a browser using an extension like Lightbeam. However, this picture is missing something. It does not take into account the information sharing between these third parties due to cookie matching and real-time bidding. And the modern advertising ecosystem is moving more and more towards real-time bidding, where a user goes online on a publisher where there is some content and a space to show ad. And this publisher is running a JavaScript from these special ad networks called supply-side platform. And the role of these supply-side platforms is to work closely with the publishers to maximize their revenue by forwarding the ad request to the most lucrative ad exchange. Let's say, in this case, to DoubleClick. And the job of the exchange is to solicit bids from its demand-side platforms, which are, again, very specialized ad networks, which work closely with the advertisers, such as Nike and Coca-Cola, and they bid on behalf of them. And depending on the information they have about the user, they will bid high or low, and someone will win the auction and reserve the right to serve user the ad. Let's say in this case, Criteo wins the auction and serve the user an ad from Nike. The key thing to notice over here is that although Right Media does not win the auction, it still sees the impression because of its participation in real-time bidding. So the process of serving this ad could look like this: from CNN to Rubicon to DoubleClick to Criteo. And the missing link is Right Media. And we take this information into account and we adjust the picture I showed you earlier on. We take into account these missing information, missing links, which basically account for the information sharing. So you can see that even though companies like AppNexus is not present on CNN, it still sees the impression from CNN due to its participation in real-time bidding. And DoubleClick was not present on Amazon, but still sees the impression from Amazon. So the goal of our study is to model the diffusion of impressions in the advertising ecosystem. In particular, we want to take into account real-time bidding effect into this ecosystem. And we want to answer the following questions. One, what fraction of user impressions are viewed by ad companies? And second, how much blocking extensions help at protecting users' privacy? And throughout the talk, I will be using and throwing some terms at you. By impressions, I mean page visits. Publishers are, for first-party websites, user explicitly visits. And by ANA domains, I mean advertising and analytics-related companies such as DoubleClick and Criteo. So in the rest of the talk, first I will tell you what data set we use for this study, and then I will tell you how we conduct our simulations using this data set. I will show you then some results, and towards the end, we will discuss how effective blocking extensions are at protecting users' privacy. So for this study, we used data from our prior work where we trained personas using more than 700 popular e-commerce websites and then solicit retargeted ads through top 150 publishers. You can read the paper if you are interested in the details, but the key takeaway is that we have inclusion chains for all resources. One of the example chain I showed you earlier on is serving this particular ad from CNN to Rubicon to DoubleClick to Criteo. And we have all these inclusion chains for all the resources. And we build a graph out of these chains. So take into account these two chains where CNN and Amazon are publishers and the rest of them are ANA domains. So the graph could look like this. The user visits Amazon and then PubMatic, DoubleClick, and Criteo. And along the edge, we also encode the weight information, which essentially means how many times party 1 sends a request to party 2. And then when the user visits CNN, this information will be integrated into the graph as well. And you can see the weight along these edges. Do notice that the weight along DoubleClick to Criteo now increases to 2 because this is the second time DoubleClick is sending a request to Criteo. So in this graph representation, the nodes are publishers and ANA domains, and the edges are publisher or ANA, publisher to ANA or between ANA domains themselves. In total, we have roughly 1,900 nodes, out of which 1,000 are ANA domains, and we have roughly 26,000 edges, out of which a majority are between ANA domains themselves. I don't have time to go into the detail of this graph, but I will give you some highlights. The graph is very dense. We did not find any distinct communities in the graph. For example, we ran community clustering algorithms, and we could not find distinct groups of supply-side platforms and demand-side platforms. So which means that the graph is very interdependent. We did run PageRank and between the centrality on the graph, and we got expected top nodes like DoubleClick, Facebook, etc. So again, to reiterate, the goal of the study is to model the diffusion of impressions in the advertising ecosystem. And to that end, we run simulations. In particular, we simulate browsing traces for 200 users, where each user generates an impression on n selected publishers from top Alexa websites. And these impressions are forwarded to ANA domains through two methods. One, direct propagation, where an ANA domain receives the impression because it was directly embedded into the publisher website, or it participated into the RTB auction and won the auction. And notice that we can observe this information because it goes through the user browser. The second way is indirect propagation, where an ANA domain sees the impression because it just participated in the RTB auction, although it never won the auction. And again, I will go back to that the chain example. And in this case, Rubicon, DoubleClick, and Criteo observed the impression through direct propagation because they were either on the website or won the RTB auction. And Right Media did not win the auction, but still saw the impression because of its participation in the RTB process. And one more thing I would like to highlight is the winner of the auction in our simulations is determined by the probability density function of the outgoing, of the weights of the outgoing edges. So let's take a detailed look into this. Consider this example graph where there are two publishers, P1 and P2, denoted by blue circles, and the rest of them are ANA domains, which are advertisers and DSPs bidding on user behalf, on advertisers' behalf. And I distinguish exchanges with red circles, and the job of the exchange is to solicit bids, but it can also forward indirect impressions. So if a node is directly activated, it will have a solid boundary. If it gets an impression through indirect propagation, it will have a dotted boundary. And in this particular simulation, we manually select 37 exchanges, 37 nodes as ad exchanges to forward indirect impressions. So the simulation would look like this. The user visits P1, where it contacted E1, and E1 places bids, asks for bids from its partners A1 and A2. Now notice that there is the weight on these edges, 10 and 90. And because of higher weight towards A2, it is more likely to win the auction, and it does. Hence it has a solid boundary. But notice that A1 also observes this impression because it got the bid request from E1. E2 then further sells this impression to A5, but the key thing to notice over here is that A4, although there is an edge towards A4, A4 never got the impression because A2 is not in our selected list of ad exchanges. Next, the user visits P2, where it contacts E2, and E2 again asks its partners to place bids, and again A2 wins the auction, so the impression counts increase for A2. A3 observes the impression through indirect propagation, and then A2 further sells the impression to A5. So this is how the simulation progresses. So that was one of the simulations I showed you from our paper. We have two more. So RTB relaxed, where we assume all ANA nodes are ad exchanges. Now this is a loose assumption, hence this model provides an upper bound estimate on the impressions observed. The second one is cookie matching, where indirect impressions are forwarded only along 200 cookie matching partners. So essentially out of 26,000 edges, the indirect impressions are forwarded only along 200 edges. And this provides a lower bound estimate. And we think RTB constraint, for which I showed you this slide earlier on, is a more realistic scenario, where we manually select 37 nodes to serve as an ad exchange and forward indirect impressions. So on this graph, on the x-axis, I show you fraction of impressions observed, and on the y-axis, I show you the fraction of ANA domains observing these impressions. So you can see that the blue line and the green line are the upper bound estimates and the lower bound estimates respectively, and the red line in between is the realistic scenario of RTB constraint, for which I showed you the slides earlier on. And the key takeaway is that RTB constraint is very close to RTB relaxed, although we selected only 37 nodes to serve as ad exchanges. And in particular, 10% ANA domains see more than 90% of ad impressions in real time in RTB constraint. So now that we know that under RTB a lot of impressions get leaked, the next question we want to answer is how effective blocking extensions are at protecting users' privacy. In this slide, I show you the same behavior I showed you in the earlier slide, but let's assume that now the user has installed an ad blocking extension, in which all outgoing requests to double-click OpenX and PubMatic are blocked. Now when the user visits CNN, the third parties view this information, but since there is ad blocking extension installed, the outgoing request to PubMatic, OpenX, and DoubleClick will be blocked. However, due to their participation in RTB and close collaboration, this information will move along from Facebook to OpenX to Criteo and so on. And you can see that all the DoubleClick and OpenX should not have seen this impression because of the blocking extension. They still do because of their participation in the real-time bidding process. And in this slide, I show the impressions observed under various blocking scenarios by these advertising domains. So we see that disconnect is the most effective. And whereas AdBlock Plus has no effect at all. And the reason is AdBlock Plus is enrolled in acceptable ads program where they whitelist majority of the popular domains. So the key takeaway again is that due to RTB, impressions gets leaked to major ANA companies even with blocking extensions installed. And in this slide, I show you top 10 domains which sees the impressions under various blocking scenarios. So we see that AdBlock Plus has no effect at all. It is no better than no blocking, where it sees more than 90% of the impressions. Whereas Disconnect is the most effective, but still more than 50% of the impressions get leaked. Under EasyList, there are no impressions leaked because in our methodology, we detect ANA domains based on EasyList criteria. So by that, they won't see any impressions. And this table shows the top 10 domains under AdBlock Plus, which sees the most impressions. So you can see that major domains like Google Analytics and BlueKai, Criteo are present over there, but some interesting ones such as Pinterest are also present, which sees more than 90% of the impressions because they are embedded in more than 150 publishers. Before I conclude, I want to mention that there are certain limitations in our simulations. Our simulation provide approximations because different users might have different browsing behaviors, and we conduct simulations based on only top publishers. The ecosystem could have changed dramatically since we last collected the dataset, which was in December 2015, and these simulations are not representative of the mobile advertising ecosystem. And in summary, we are the first to provide a model to study the impact of real-time bidding on users' privacy. We run simulations to see that more than 10% of ANA companies, ANA domains view more than 90% of the impressions under realistic scenarios. And we also saw that even with blocking extensions installed, a majority of user impressions are leaked to ANA domains. In particular, AdBlock Plus is not effective at all because of its participation in the acceptable ads program. Our dataset and code is present on this link. And with that, I'm happy to take questions. Thank you very much.
Any questions for the speaker?
I'm wondering, when you say leakage, what exactly is being leaked, especially on the server-to-server requests? Because it's possible that an exchange is actually potentially key, especially if like the participating bidder maybe isn't allowed to receive that cookie, especially as GDPR is coming out. There's more GDPR consent tokens coming in, and exchanges that are abiding by those might not be exposing the user's cookie or even the user's IP address to the participating DSP, and therefore the DSP will receive the impression, but the DSP is not necessarily receiving any user information. So I'm wondering sort of like how you would classify leakage and how you could potentially like enhance your data set to get insight into like whether or not user privacy is being violated on these server-to-server requests.
Yeah, I think that's a great question. We haven't looked into these particular details like in the effect of GDPR and particular PIIs. When I say information leakage, I am talking about impressions leaked, and in particular, I mean page visits, like CNN. We do not look in specific like whether like the username is being leaked or like email address is being leaked, but that's a very interesting avenue, and we should explore that definitely.
So we just heard another talk where people were training up things to sort of not just have a simple list. And I realize you haven't already done analysis based on the talk you just heard, but I was wondering if you might speculate about how that might impact the leakage that's going on if you're using something that's smarter like that.
So that's again a very great question. I showed in one of the slides that when I was showing the top 10 companies, that EasyList we don't see, because by default our detection methodology is EasyList. But if you're using something like uBlock Plus or NoScript, it's even more effective. But again, I would like to show one slide over here. So we also selected only 5, where in our simulation, where I said we select 37 exchanges, we also run with various different exchanges. So you can see that even with 5 exchanges, a lot of information is leaked. So even if like those 5 big players are present, they can still leak that information because the advertising ecosystem is so dense. Like if some of them see this information, the information gets propagated very quickly.
Any more questions? To follow up on the first question, what exactly does an impression typically look like? Like, I mean, you said you're not sure, but like, what are these things?
So we just say that page visit, but essentially when a request goes from an ad exchange to a demand-side platform, it would tell a lot of other things. For sure, cookie as well, because demand-side platform has to identify the user to place bid effectively, and that request could entail other information as well. For example, the website. It could also, I mean, other researchers have shown that sometimes like more PII is even leaked. So we haven't looked at in particular details, but for sure that can also get leaked.
Thanks.
Yeah.
All right. Thank you. Okay, so next we have Jeremy Martin, who is going to be speaking us about exploiting TLS for more tracking.
Hi, Jeremy Martin. I'm representing the Naval Academy on our work on user tracking. That's not showing up, is it? Sorry about that. The paper discusses user tracking using client certificates over TLS. Lucas Foppe was actually the lead researcher on this, but he couldn't make it today, so I'll be presenting on his behalf. Is that better? All right, so the normal use case for certificates in TLS is when the server's trying to prove to the client that it is who we say it is. So the client says hello, server sends back an identity via its certificate, and they get negotiated encrypted comms after that and send their data across. But how does a client actually do this? Well, it's very similar. Normally, though, we send a password, but sometimes this just isn't practical or we want to try something else. Luckily, TLS offers another solution via client certificates, and we're going to walk through how that has a large implication in privacy and tracking. Previously, this wasn't a wide studied topic via the rare use case for client certificate authentication, but we see with digital ID programs with Estonia, Finland, chip cards for corporate PINs, as well as IoT devices and 802.1x EAP authentication. So the problem with client certificates, where we don't see this in the server side, is that public information is transmitted containing private identity information such as your email address, your user, and unique serial IDs. This is a problem, obviously, if you're able to collect this at a wide scale. This has previously been documented in several papers, and we'll talk about those use cases and our extensions on them. As we discussed, previously we thought about client certificate usage as a rare case, but one widely reviewed discussion is the Apple push notification system, where all Apple devices, iCloud, iTunes, are actually using client certificates to talk to the Apple push notification servers, and those are contain a unique serial number. A previous paper by Walks and his team discussed how these were being transmitted in the clear. So we'll talk about that previous use case, their mitigation strategy to make sure these client certificates were no longer passed in the clear. And then we'll talk about 3 of our attacks that break that mitigation strategy that Apple employed. So we'll start off with that discussion here, where we look at the old issue where a passive attack was employed by Walks. Here we see the version 2 layer extension by Apple push notification server in their client hello. The server responds with the client request and its certificate all in the clear. And then you see the client certificate sent in the clear. Walks and his team showed that with 12.5 or so points of presence on the internet, they can intercept the majority of this push notification traffic. So they later worked with Apple to mitigate this, and as you'll see, they simply changed the extension to version 3, in which the server responds with the certificate, but no longer a client certificate message. So they began their encrypted comms setup, and then you'll see the client request and the follow-on client certificate are now encrypted and no longer available for passive retrieval. So now we're going to talk about how we inspected this, read through their paper, and found a few flaws in this system. All right, so the first one is actually a downgrade of their new extension. You see the client sends a version 3 extension message. We simply flip 1 bit and change that to version 2 when we're an in-path attacker, where we're able to both receive the frame and modify it. So we just change that frame, push the downgrade attack to the server. It goes back to its previous, prior to the mitigation setup, sends the certificate of the server, still sends that client request, and we get that client certificate back. The next attack is actually a replay attack. This is useful where maybe we only see one side of the traffic. The client hello goes to the server, but we see that server response. And when that certificate comes back, we just add the certificate request back to that message stream. And we get that certificate back from the client. So 2 methods there, using an in-path attack to get the client to still respond with the client certificate. Our next attack is an on-path attack. In this case, we are only able to observe the traffic and not modify it. So we actually we're in a race condition here where we need to replay something, spoof the server before the server gets its actual valid response to the client. It's a little more difficult. This is because the default response from the server is a server certificate that uses elliptic curve, which has a signature to mitigate replay attacks like this. So the first thing we do is we actually set up a client hello where we've removed all of the all the elliptic curve cipher suites and extensions and some other tweaks in there to force the server to respond back with a certificate that's using RSA. So that's stage 1. We do this offline, have this pre-staged. Now in stage 2, when we observe but can't change a client hello using the mitigated strategy version 3, we then just replay all of the information that the server should be responding with, but we use that RSA-based certificate and certificate request in which we elicit a response back from the client, and we get that client certificate. All right, so those were all iOS Apple-specific attacks that we used for this methodology. However, the last 2 are actually applicable to TLS CCA as a whole. We actually took a look at some of the other implementations. Back in 2014, there was a paper looking at Estonia's use of websites with client authentication over TLS, and they found that 1/3 of the websites were still vulnerable to this passive attack, where all they had to do was listen to the traffic, extract the certificate, and they had the email addresses in there, a lot of user-based information. That was bad. So the first thing we did is go look at those same sites and see if there was an improvement. There was actually a decrease, and more of those websites had actually went and reverted back to using sending everything in the clear. So even though there was a mitigation strategy proposed in that paper to turn on a few server tweaks there, to at least move it so that the public disclosure of that information wasn't in the clear, people weren't using that mitigation strategy. Furthermore, the 2 attacks that I mentioned that weren't specific to Apple still work against the servers that are properly using that mitigation strategy. Finally, we discussed why this is a very difficult problem to address in a broad sense. Apple is able to deal with this because they own the entire ecosystem. They own the server side and they own the client side. They can push that entire request system up to the application layer, in which they were able to mitigate it after we disclosed it. This doesn't work when there's browsers and servers that aren't owned by the same entity. TLS 1.3 was just recently adopted, however, it's not widely implemented, and even when it is, if they allow for downgrades to TLS 1.2, our attacks will still work. Just quick highlights of the resolution, our responsible disclosure. We worked with Apple, we gave them all our results and worked to help mitigate the solution. They sent out a patch and you can see they no longer are vulnerable to this attack after these upgrades. Any questions? Thank you.
Any questions?
Does the attack work on GCM, Google Cloud Messaging?
I'm sorry, I wasn't able to hear you.
Does the attack work on Google Cloud Messaging?
GCM?
Yeah.
We attempted to use this attack against them, but they did not respond with a client certificate.
Thanks.
Any more questions? Okay. Sorry. The third. So I was a little confused as to why the first two attacks were Apple specific. Can you clarify that a little bit?
Sure. So the first two and the diagrams are Apple specific because we attacked their servers here. So the first one only works against Apple due to the fact that we're downgrading their version system where they switch to version 3. They tell the server, hey, we're expecting that the client request is coming after we negotiate the encryption. So that only works because that is an Apple extension that's being utilized. So that's definitely only used for Apple. The next two are actually employable against all CCA.
I'm not a TLS expert, so pardon me if this is stupid, but there are a lot of other implementations. Do you have any sense what fraction of the different implementations of TLS are vulnerable? And did you just find, because you focused on Apple, did you just find the one bad one?
So this is a flaw for all TLS 1.2 and down, and once 1.3 is available, if they still allow downgrade, it'll be a TLS wide, but it's a client certificate problem. So Apple is the most widely seen ecosystem utilizing it. We observed IoT devices using this as well, which would be vulnerable. The digital ID cards where you're authenticating to like a government website with your digital ID, similar to Estonia's digital ID cards, they were all susceptible as well. The biggest use case and the premise for our original attacks was just specifically Apple. So anyone that's using client certificates, a passive attack, if they're not actually waiting until after encryption is established, as a widely available and known discussion, we just started there and then looked at the mitigation tools that are being used there and found that we can break all those mitigation. Great question, thank you.
It's probably a stupid question, but because I didn't understand something, but so all of these attacks presume that you're sitting between the client and the server, right?
Yes, so you're either in path or on the path, so you're actually
Right.
able to either see and modify or just observe.
If the impact is user tracking and you're actually sitting between the client and the server, don't you already know who the client is? What is the, don't you have bigger issues than this if you actually are under this assumption?
Can you say that again? I'm sorry.
The impact of the attack is user tracking,
Yep.
right? But if you're sitting on the network and you know who people are,
Okay, yes. So an example would be you have your nation state actor and you're on an ISP and you're just one of these routers that are in between one of the actual servers conducting the authentication. You have really no knowledge of, just because it's sitting behind some IP or NAT, who the clients are behind there. So this can actually be done on backbone networks. That's a great question. Thank you.
I also, in line with everyone else, don't know a lot about certificates, but why do they need to contain PII? Like, is it necessary?
Yeah, so not all of them contain usernames, email addresses, but largely the digital ID folks keep that information there. So Apple, there's no PII in there, but there's a unique serial number. So at any point you were able to associate that to somebody you cared about, that serial number will be the same every time. So let's say you're in a Wi-Fi cafe and you're actually know that the MAC address is who you care about, possibly, and then anytime you're on an ISP now and you see that serial number that you correlated to the unique device, you can track it across the network. Is that, thank you.
All right. Thank you, everyone, for this lovely first session. And we will see you at 11:30 for the keynote. Is that true?
If the speakers for the first session in the afternoon could come find me. My name is Matt Wright. I'm wearing a Luke Skywalker t-shirt.
Oh do you want to? That's right. You should have been a session chair. All right. Thank you, everyone, for coming back from the break. So right now we're going to have the keynote speaker, Alan Mislov. He's a professor at Northeastern. He's also, I believe, raised to partial deanhood. Associate dean, yes, at this point. But he still finds time to do some really amazing research, and he's going to tell us about some of the stuff that he's done, kind of uncovering the privacy properties of kind of targeted advertising on online social networks and things like that, and some opportunities I assume to potentially improve the privacy of these systems and stuff like that. So without further ado, I will hand it off to him. This is also a longer talk. It's going to be broken into several segments, so feel free to interrupt him. Within here, also, who's monitoring the online feed? Can you stand up? The student that's supposed to be... Yes. Yes. Okay, so you're... Okay. Okay, so also feel free if we have non-spammy questions to chime in with those as well. Okay, thank you. Okay, without that...
Great. So thank you very much. As Damon said, my name is Alan Mislov. I'm at Northeastern University. I'd like to start by thanking all of the organizers for the invitation to come and speak here, Carmela, Rachel, and Damon. And just echo what Damon said. I like very interactive talks. I know keynotes aren't really supposed to be super interactive, but instead of talking at you for an hour, feel free to interrupt. And if you have longer questions, let's save it to the end. But if you have burning questions, feel free to just raise your hand. I'm more than happy to stop. So what I'm going to talk about today is some work that my group has been working on for about the past year and a half or so. And we started working on the area, looking at targeted advertising, and we started getting a couple of papers published. And then one day, I woke up and I had a pile of emails from reporters in my inbox asking about targeted advertising. And so you might be wondering, well, what happened? Like, my papers don't get that much press usually. And what happened was Cambridge Analytica. So about 4 months ago, most of you probably know this, Cambridge Analytica, the story came out that they had partnered with some researcher who had collected data from a Facebook app. They had data on 80 million users, and basically the entire press freaked out about this. And so I started talking to some of these reporters, and for those of you who've talked to reporters, you sort of want to understand what their angle is on the story before you figure out exactly what you want to say. And I found that basically the reporters I talked to had two different angles that I tended to see. The first was just freaking out about how did Facebook get all this data, right? And I'm sort of like, well, that's, that horse has left the barn, right? Like, that's their business model, which is like not super interesting, but it was, of course I'm happy to talk to them. The second angle was, well, a little bit more subtle, like how did Cambridge Analytica in particular collect all of this data? And that's an interesting discussion because it involves Facebook app permissions and, and so forth. Many of the people in this room probably know sort of how they were able to do this, and we all know that My Personality was certainly not the only app to collect this kind of data, right? But it didn't really touch on exactly what I thought was the most interesting aspect of the story, which is why did Cambridge Analytica collect all of this data? In particular, what did it allow them to do? Why were they trying to get profiles on so many users? And if you want to understand why Cambridge Analytica was trying to do this, you really, it's sort of hard to answer that question because the people who know are either Cambridge Analytica or Facebook, and I'll promise you neither one of them want to talk about this, right? So you have to look elsewhere. And one of the places you can look is as a result of the Cambridge Analytica fallout, Mark Zuckerberg was hauled in front of the US Senate and had to testify. The US senators after that, they sent Facebook a long list of questions that about 3 weeks ago or so, Facebook responded to. And you can read through this, it's all public record. And there's about a 500-page document of Facebook responding to follow-up questions from the US senators, right? And if you dig through that document, you'll find the following statement. They said, Cambridge Analytica generally utilized custom audiences, some of which were created from contact lists and other identifiers, and in some instances, refined those audiences with additional targeting attributes. So my question to you is, how many of you know what that means? Great, like 4 of you. Okay, so what I decided to do in this talk was actually, before I get into my work, just give you some background, such that we all understand what this means, which will then help you understand what our work is all about. Okay, so bear with me for about 10 minutes, and this will mostly be background. So to explain all of this, we need to take a step back and talk about targeted advertising. So imagine you're an advertiser. One of the things you're most concerned about is who sees your ads, right? So ideally, everybody would see your ads, but unfortunately, you don't have that kind of money, right? So instead, you have some subset of users who you believe are receptive to your ad, right? They may be previous customers, they may be people like your previous customers, or whatever, right? So the way I've sort of pictorially represented this is all users are here, and the users you really want to hit are the ones in blue here, okay? Now, if we think before the internet, the best way you had to target were basically broadcast media. Things like newspapers, magazines, periodicals, this sort of thing. But that's an extremely coarse-grained way of targeting, right? So if you imagine it from this visual here, like you can sort of narrow it and kind of get your blue users, but you're gonna get a ton of other people, right? And so what started happening when the internet came around is you could actually get more fine-grained targeting. So if you think of like, say, Google Search is one of the first big advertising networks, you could now, because the mechanism or the medium is inherently personalized, you could start slicing and dicing your audience much more fine-grained than, say, a TV broadcast do, because it's a broadcast medium, right? So you start seeing search keywords getting you even closer to the audience, to sort of your ideal audience. And then, starting about 2008, 2009, Facebook advertising really came into sort of maturity, and this is what you think about, or you're probably thinking about, when I say online social network-based advertising. Advertising based on user attributes. So let me take a minute explaining exactly what that is and what started when Facebook started doing this in about 2009. So the way to think about attributes is they're basically tags or features associated with user accounts. So those features can come from a number of different sources. They can be platform activity, so like in the context of Facebook, based on like what you self-report in your profile, or in Google, like what you search on or something like that. It can be based on third-party web browsing, so many of these services have trackers, as we heard about this morning, and they infer information from that. Or it could be inferred from partner companies. As you'll see later in the talk, a lot of these companies partner with other companies, they match their database, and then get additional attributes that way. So if you ever look at the advertiser interface for these services, it's actually quite powerful. You don't just have to target one attribute. You can actually create Boolean expressions over attributes. So I can target like men who live in Boston who like this band, but who don't match this other attribute or so forth. So you can actually create really complex expressions over these attributes. And this is present on most major advertising platforms, and I'll spend a minute going over those. I'll say that most of these platforms are opaque about where exactly the data comes from. They'll sort of say some very high-level things. And some of them do offer limited transparency features, but we've done studies showing they're quite limited. And so I'm happy to take any questions about that sort of at the end of the talk. But to give you an idea of what this looks like, if we look at Google, this is Google Displays Ads set of attributes. There's 4 different attributes you can target: age, gender, household income, and parental status. They divide it into very coarse-grained buckets, things like ages and so forth. In terms of where they infer this information from, for users who are signed into their Google account, they say this is based on settings or activity on Google properties, some partner sites, mobile device activity, so using Android to do this. They also infer attributes for non-Google users, and they say that's based on your activity on and off of Google. If we turn to Twitter, Twitter offers a few more. You have your gender, age, language, location, mobile device type, and now we start getting into like interests and behaviors and so forth. A lot of that is inferred from both profile data, things they call factors of account likeness, which is, I have no idea what that means, and other things such as user attributes, such as the accounts a user follows or that user's interests. So they're doing some sort of machine learning on the graph and based on what you reach. But now let's turn to Facebook. Facebook has over 1,100 well-defined attributes. I'll say exactly what I mean by that in a couple of slides, but these are ones that there's a very particular hierarchy of the attributes. These include all the basic things you've seen so far, as well as more sensitive attributes, things like relationship status, political leanings, income level, net worth, purchase behavior, and so forth. And again, like any other system, you can target Boolean expressions over these attributes. And they come from not only user profiles, activity on Facebook, as well as partnerships with third-party sites. Okay? Any questions about attributes? Most of you are probably somewhat familiar with this. Okay. So let's go back to my little graph here. Again, with attributes, that's getting you closer to the set of users, but it's still not quite exactly the set of users you wish to target as the advertiser, right? So what's the end game? What's the best thing you can do? Well, what if you, as the advertiser, could literally target exactly those users, the users who you know you want to target. And I'll argue you can actually do that today. So there's something called PII-based targeting. So the way this works is quite different than attributes. Literally, if you're the advertiser, you put together a list of your customers. And you take whatever PII, personally identifiable information, you have on them. So I'm talking email addresses, phone numbers, whatever else you got. Upload that to the service. And the service will actually match against their user database. Service comes back and tells you, okay, you uploaded 1,000 records, we found 500 of them, and now you can advertise to exactly those 500 users. And so if you're an advertiser, there's two reasons why this is very, very attractive. The obvious reason is it lets you get really close to exactly the set of users you want to target, right? In other words, you're not paying to show ads to people who you don't want to target. So it's a very efficient way to use your advertising budget. That's the obvious reason. The non-obvious reason is that this basically grows the advertising ecosystem. Because what it lets you do as an advertiser is ingest data from all of the sources of public data that are out there, and then integrate that into the advertising system. So what I mean by that is, like in the US, property records, criminal records, voter records are all public. In many states, they're free. And there's also a whole ecosystem of data brokers that collect and buy and sell data on people. And so what this means is now you as an advertiser can figure out who you want to target off of Facebook, and then go to Facebook or Google or whoever, upload their PII, and match against exactly those people. To show you how this works in practice, I'm going to walk through a few different examples. So we're going to look at things like the different features, how many PII fields you can match on, how big the audience has to be for you to advertise, and then I'll talk for a minute about hashing, because they're very concerned about hashing for reasons that'll become clear in a second. So the first of the services is called Google's Customer Match. So I have links down here at the bottom if you want to take a look at these. Basically what you do is you can upload 7 different PII fields, email, phone number, first name, and so forth. When you do that, you have to have a set of at least 1,000 to be able to use it. So if you upload less than 1,000 users, you can't use the resulting audience. You can't actually advertise. And they advertise, and they say that all of the data before it's uploaded to Google is hashed in order to keep your data secure. Okay? Let's move on. Next is Twitter's tailored audiences. So again, they have 4 PII fields that you can match on. This includes email address, mobile phone numbers, mobile advertising IDs. These are the things that your phone gives to the apps, and Twitter handles. And again, the minimum size there is 500 users to be able to target. And they say that the data is hashed so that Twitter never reveals or shares your information in your list with anyone or any other service. So they're quite concerned with privacy for the advertisers, not quite so concerned with privacy for the users. If we move on and look at Facebook, Facebook's custom audiences that you'll hear a lot about later in this talk, they actually have 15 different PII fields, including things like name, date of birth, email address, phone number, and so forth. On Facebook, the minimum size is 20 users. So you can advertise to a group as small as 20 users. And again, it's hashed. It's hashed using no salt. It's just uploaded the data, again, ostensibly to protect advertiser privacy. What's interesting? Yeah?
Is the minimum size the size that must match?
Yes.
Thank you.
Okay. Finally, there are other services that have this, including Pinterest. They have something called audience targeting. LinkedIn has something called account targeting with different number of fields and different minimum sizes. But they're all basically exactly the same service. They let you upload PII and then advertise to exactly those users. Okay. Other questions about this while we have you here? Nope. Okay. So let's go back to my sort of diagram here, right? So now we're at the point where we can literally target exactly the people we wish to target. But these platforms say, well, actually, we know much more about these users than, say, you as the advertiser does. So we could potentially offer you another service, which is we can say, okay, you're targeting this group, but we know other users who are kind of like that group, right? Potential future customers for you, right? So what if the platforms could then say, okay, well, we're going to expand your targeting group and recommend other people who are like this particular group. So this is called lookalike audiences. And again, the way this works is you upload your PII to the Ad platform, it first matches the users and then finds other users who are not in your set who are like those users. And if you look at sort of the documentation that they say things like, we identify the common qualities of people in the audience, and we find people who are similar to or look like them. Again, this is common across multiple platforms. Facebook has something called lookalike audiences, upload a source audience, and then you can choose the lookalike audience is between 1% and 10% of any country's population. Similarly, Google has similar audiences. They use machine learning to understand what they have in common. But notably, with Google, you can opt out of this in your advertising preferences. And finally, Pinterest has act-alike targeting, and you choose the percentage of the audience, the lookalikes, who are some fraction of the entire Pinterest user base. Okay? So let's go back to this quote. Cambridge Analytica generally utilize custom audiences and so forth. So what does this mean? Well, what it means is they were uploading PII, that's where custom audiences come up from, using contact lists and other identifiers. And then they were refining those using additional targeting attributes. Because remember, once you've created an audience, you can then go and slice and dice that audience in various ways. So if I upload PII, Facebook will come back and say, okay, now I've matched those users, and then I can say I only wish to advertise to the users with particular expressions over attributes. And that's basically what they say Cambridge Analytica was doing. Okay? So in this talk, what I want to do is take a step back and look at this entire ecosystem of targeted advertising. I want to try to understand what the risks are and whether there are actually any opportunities that they could help users to understand a bit more about this ecosystem. For the rest of the talk, I'm going to focus primarily on Facebook because, as you've seen, they're sort of the richest service, they have the most features and so forth. We haven't looked at the other systems, so I can't make any statements about whether they are vulnerable to the particular things we found. But the key questions we want to understand are there unique security or privacy vulnerabilities? How could these mechanisms be potentially misused? And are there any benefits that we can bring to end users? And if there's time at the end, I'll talk a little bit more about what I see as a broader research agenda looking at today's targeted advertising. Okay? So, before I go into the first section, any questions? Yeah?
Has GDPR changed anything in terms of users actually being able to get, for example, what is the list of lists that they're in or stuff like that?
That's a great question. I haven't looked at that. It would be very interesting to be able to ask, you can ask the services to give you this information. I haven't seen any changes to the transparency services that we've studied, but we're US based, so perhaps they do something different for Europeans. So I think it's a great question, but it's something we haven't seen anything about. Any other questions? No? Okay, so let's go ahead and get started. So the first thing I want to talk about is discrimination. So this is based on a paper that we published at FatStar earlier in the year. You can find it on my website. And what we're going to look at is discrimination in advertising. And so if you follow the literature here, there's been a number of press reports about how advertising services could be abused by advertisers who wish to discriminate in various ways. And so in the US, there's actually very sort of a hodgepodge of rules that speak to discrimination in advertising. In particular, the rules are different for what kind of ad you're trying to place. So the three most relevant laws in the US are, first, the US Fair Housing Act, which says that it is unlawful to make, print, or publish any advertisement with respect to rental or sale of a dwelling that indicates any preference or discrimination because of race, color, religion, sex, handicap, familial status, or national origin. Okay? So basically it says you can't run an ad that indicates any of these preferences. The second is the US Age and Discrimination Employment Act, which, if you read this, basically says it's unlawful to run an ad expressing a preference for age when you're advertising for employment. And the third is the US Equal Credit Opportunity Act, which says that creditors who are advertising for credit opportunities can't express preferences along different protected classes. So these are the three areas we're going to focus most closely on. And one of the sort of the incidents that happened that brought this to the forefront was ProPublica was looking at Facebook's advertising system and noticed that among the 1,100 attributes that Facebook had, some of those had race in the name. They were called multi-ethnic affinity or something like that, where basically it was like they had different attributes like African American affinity, Asian American affinity, or so forth. It was sort of a proxy for race. And so what ProPublica asked was, well, could we run an ad advertising housing or targeting users who are looking for housing and then include or exclude people based on these ethnic affinity attributes? So they did it, and shockingly, Facebook let the ad run. And so what happened was ProPublica then reported this because they're a news organization, and Facebook came back and said, oh my gosh, we're so sorry, we'll never let this happen again. And what we're going to do, the way we're going to mitigate this, is we're going to ban those particular attributes for this particular class of ads. So to quote Facebook, they say ads promoting housing, employment, or credit opportunities can't be run using multicultural affinity targeting. So what that means is if you're using these attributes, you can't run housing, credit, or employment ads. So the question is, are we done? Does this fix the problem? Answer shockingly is no, it does not. So in this work, what we're going to do is look at all of the other targeting features that I talked about 5 minutes ago, and look at other ways that advertisers could implement discrimination if they wish to, based on these other features. And we're not going to talk really about who's liable, because that's really a question for the lawyers, and there's actually some debate about, is it the advertiser, is it Facebook, and so forth. But rather, we're just going to look at to what ability do advertisers have if they wish to run these sorts of discriminatory ads. But one of the key questions we have when sort of doing this sort of analysis is how do we measure discrimination, right? What exactly do we mean by that? And so there are a number of different ways that you can measure discrimination and metrics you can use. There's one in particular we chose to use that's sort of intuitive and it's easy to understand, but again, there are others that you could use if you prefer. The measure we picked is called disparity. So let's imagine we have our set of users here. This is all users, say, on Facebook. And let's imagine that the attribute we care about is a binary attribute. So you either have it or you don't. So, so I'm coloring the users red or blue for this context. Now, when you're running ads, not all ads are relevant to all users. So one example for this is like if you're advertising men's clothes, then the people who are most receptive to that are probably going to be men. And so we wouldn't necessarily want to say if I'm running an ad targeting men for men's clothes, that's not really discriminatory, at least in sort of the way we normally think about it. And so the way you sort of address that is you have this notion of what we call a relevant audience, which is the idea is these are the users for whom the ad is relevant. And so in the case of, say, men's clothes, it would mostly be men. And now we look at the targeted audience. I mean, who did the advertiser ultimately ask Facebook to show the ad to, right? So the way you measure disparity is you simply say, okay, well, what fraction of the relevant audience was in the targeted audience? So we look at, say, the red users with the red attribute, and you see there's 6 of them in the relevant audience, 5 of them ended up in the targeted audience. Same thing for the blue users, 3 in the relevant audience, 1 in the target audience, and the disparity is simply the ratio between those two. So in this case, the disparity would be 2.5. And what this means is that if that disparity is far away from 1, that means you're biased either towards or away from the particular attribute. If you're close to 1, basically you're targeting users with or without the attribute at relatively the same rate. Make sense? Again, there are other metrics you can use. This is just the one we choose to use. And so now what we want to do is turn and ask, okay, of all the other targeting features, are there ways that we can implement discriminatory advertising? And so the most obvious way to do this is to say, okay, well, in the ProPublica study, they were asking Facebook to do the filtering. They were saying, hey, Facebook, start with all users and now filter them based on ethnic affinity. What if the advertiser instead did their own filtering and then went to Facebook and uploaded those users' PII who they ultimately wanted to target? Right? So we sort of played the role of an advertiser, and we went and we downloaded the North Carolina voter records. And what's interesting about North Carolina, it's one of the states that voter records are free or they cost some small amount of money, but they have gender and race and user's address in the voter records. So you can actually use this and then go to Facebook, and this is all public records. And so what we did is for every protected attribute, for gender, race, and so forth, pulled out 10,000 users out of the public voter records, uploaded those to Facebook using PII-based targeting, and then observed what fraction of those users did Facebook ultimately match. Right? We're sort of implementing discrimination, but we're doing it offline and then going to Facebook and asking them to just simply match this list of users that happens to be a highly discriminatory audience. And what we saw is you're able to match a very large fraction of the audiences, depending on your attribute. So for example, if we pick out the women in this in the voter records, we're able to match 70% of them. If we pick out African Americans, so users labeled as black, it shows up as 63%, and older users, it shows up as 41% of them match. What this means is it's basically trivial for an advertiser who gets offline data to implement discrimination by simply uploading their PII to Facebook.
Yeah, if you would all control for, whether or not the voter registration lists for themselves had discriminatory problems.
They may. We were just using them as ground truth, right, in this particular example.
But I mean, we're already perhaps starting from a non-representative.
Absolutely. Yeah, you're absolutely right. And again, we could have gone to data brokers, we could have gone to other sources. We're just looking at how easy would it be for an advertiser who wished to do this offline to do this, and it's pretty easy. Okay. Yeah.
So this is probably a question for the lawyers and not you so much. But so in the text of the laws that you showed earlier, I don't have them exactly in front of me still, but I thought it said something like you can't post an ad expressing a preference for a particular protected class or whatever. So technically, is this violating that? Here the ad doesn't say only this class or not this class. It's just you're only showing the ad to class and not that class.
Yes, that's an excellent question. It is absolutely a question for the lawyers, and I will say just I'm not making any statements about any company being liable. Please don't quote me. But I will say that there are cases we've just had some informal discussions, and one of the distinction appears to be who's doing the filtering and how actively involved is the platform in the filtering, right? So in other words, in cases where as you'll see later, there are cases where Facebook does a lot of the selection in this example, or this is a case where the advertiser's doing the selection, so that may impact who it is. But I will say, in terms of expressing preferences, there are the ad explanations. So if you ever right-click on a Facebook ad, it's got why am I seeing this? That will tell you the attributes that the advertiser is targeting. One of the attributes the advertiser is targeting. So you could, or it will tell you the ages. It always tells you the age. Right? And so there are indirect ways where there is information embedded in the ad about how the advertiser wished that ad to be run, if that makes sense. So, but ultimately it is absolutely a question for lawyers. Other questions? No. Okay, so that's method number one, was simply using PII. The second is using attribute-based targeting. And the idea here is, Facebook banned 3 attributes, the ones that are, on their face are discriminatory, are basically representing protected classes, so race. But of these 1,100 attributes that we talked about a minute ago, and an additional 250,000 what we call free-form attributes, things like you're associated with a particular page or these sorts of things, could those be heavily correlated with the protected classes? And so to understand that, what we're going to use is the estimates provided by Facebook. So whenever you go to place an ad, the way it works is you specify using this interface exactly the parameters you want to target. So you specify the gender, the age, any attributes, and so forth. This is where you enter that Boolean expression. And then before you actually place the ad, Facebook will tell you right here how many users match your particular targeting parameters. And so what's nice about that is we can look at other attributes and see how close their intersection is to the attributes that we care about. So the way we did this is, again, we started with our ground truth, our North Carolina voter records, uploaded those, and then picked records of protected classes like we did before. And then we saw, well, for every attribute, what fraction of the group we uploaded also had each one of these other attributes. And so from that, we can measure disparity. We can also measure prevalence in the underlying population. Just to give you a very quick snapshot of these results, what it shows is there are many attributes out there that are just as discriminatory as the attributes that Facebook banned. So in other words, in the US, looking at trying to select black users, if you want to include them, African American affinity has the highest disparity, but there are others like US politics, very liberal, and interest in online games that have similar levels of disparity and similar levels of prevalence in the audience. If you wish to exclude those sorts of users, then there are other attributes that have very low prevalence of African American users. So for example, US politics very conservative, the disparity is 0.18, meaning you're getting many fewer users, black users, relative to the underlying population. Right? So the point is that there's many other attributes out there that you could use that are proxies for the band attributes and are sort of facially neutral if you just simply look at them with respect to race. And again, when we're looking at this, we're only looking at single attributes. You can create Boolean combinations of these things, so potentially you could actually refine these in many ways to get much more accurate targeting. Okay? The third method we looked at was lookalike audiences. This is what I talked about a minute ago, where it grows your audience. And so again, what we did is we started with sets of 10,000 users and then asked Facebook to simply find us more users like those, and then we measured the disparity of the larger set. And so the x-axis on this graph is how big we asked Facebook for the lookalike audience to be. So it's starting from the source up to 10% of the entire US population. And the y-axis is the disparity, meaning how biased was the resulting set. And so what you see is the lookalike audience feature works quite well. It finds users who look like the set we upload, right? So the disparity here, for example, for black users is up around 25. And this may sound, we're only looking at 2% of the population here, but that's 6 million users. And so our concern here is that this basically allows advertisers to amplify any sort of discrimination. If you can find a source audience that captures what you're trying to do, you can then ask these services to expand your source audience and have a larger set of users who share the attributes of this smaller set. Okay? So the summary of this part is, as we saw, all three targeting mechanisms can be abused. If you want to ask who's liable, please talk to the lawyers, not to me. But in terms of sort of how to address this, our feeling is that Facebook's approach thus far has been a process-based approach. So they looked at how did you choose this audience, and they're going to ban particular mechanisms for how you chose it, right? So you're banning particular processes. But we think that ultimately that's going to be sort of like a whack-a-mole game. There's always going to be other ways that you can get the same users. And so instead, what we're pushing for is an outcomes-based approach. Meaning you look at the ultimate set you targeted, regardless of how you got there, and then measure the disparity there and ask, is that allowed or is that not allowed? And this has some nice parallels with disparate impact in the United States, which is sort of a legal measure of whether discrimination is allowed in sort of hiring processes and so forth. And it's very similar in the sense that it says, I don't care what your process is, I'm ultimately just going to look at the outcome. And if your outcome is biased beyond an 80% threshold, you need to justify why that exists or it's illegal. Okay? So before I go on, any questions here? Yeah, so I think that's a great question. In case you didn't hear it, her question was about how should Facebook implement this, and should Facebook be responsible? Is sort of the essence of the question, right? Yeah, so I would argue, yes, Facebook is best positioned to be able to do this. And they're actually doing this already in other contexts. So with political ads, Facebook already is flagging them, and they have this special process for political ads now that I'm happy to talk about offline. But they are the ones who are seeing all the ads, and they're the ones who know these attributes. So they could actually do simple measures of, when I'm about to run the ad, is this biased in a particular way? And if so, maybe I go back to the advertiser, or I don't allow the ad, or whatever, right? So it's an interesting question, but it's one that I think the advertising platform is best positioned to enforce. Any other questions? Okay, so the next thing I want to talk about is a different kind of risk. And in particular, it's looking at privacy leaks. And so this is a paper that we published in Oakland this year. Again, link is on the bottom of the slide. I'm sorry if you can't see it. It's on my website if you want to read it. So to understand what we were looking at here, we need to go back to 2011. And so Alexandra Korolova in 2011 was looking at the Facebook advertising system. And the system back then was very different. It really was only attribute-based. It didn't have any of this PII stuff. But what she noticed was that suppose she could find a combination of attributes that uniquely identified you, right? So, some Boolean expression over these attributes. And if she could do that, what she could then do is infer all of the rest of your attributes. Because what she would do is she would run an ad with the set of attributes that uniquely identify you, and she'd add on one more attribute. And if that ad had an impression, what that told her is you matched, meaning you had that attribute. If the ad did not get an impression, it means you didn't have the attribute. Everyone follow? And so what she was able to do is actually enumerate all of the attributes using Facebook's thing. So she reported this to Facebook, and Facebook said, oh my gosh, we're so sorry, we'll never let this happen again. And what they did was they said, okay, whenever you run an ad, you have to have at least an audience of 20 users. So this is where the 20 came from. And so this still exists today, right? So if you're targeting a set of users, if you have less than 20 in this audience, then they won't let you run it. Even back then, she pointed out that fake accounts and whatnot sort of make this somewhat dubious, but basically this has existed until today. But as I said before, PII-based advertising was introduced in the interim. And so we want to understand, could PII-based advertising be leaking information in the same way that Korolova found that attribute-based targeting was leaking information? So let's take a look at this diagram that I have here. So essentially what's happening here is the advertiser is uploading data to the platform, and the platform is coming back and saying, here's a size estimate, here's how many I matched, right? So you take a step back and sort of squint a little bit and turn your head, this kind of looks like a database query, right? You're uploading a bunch of data, you're getting back a statistic. So what we're worried about is, could these statistics be inadvertently leaking information? And this is especially worrisome because anybody can be an advertiser. You just go to ads.facebook.com and click I accept, and there's no cost to uploading this data. You only pay when you actually run an ad, right? So getting these statistics are actually free. And so what we did is we spent about a few months really studying how Facebook's advertising system worked. How did they match PII? How did they give us these statistics and so forth? And what we found were there are two interesting properties of their system that both seem reasonable, but that together allowed us to conduct a number of attacks. So let me tell you what those two properties are. So the first is we looked at the size statistics that Facebook reported back. So we'd upload a list, Facebook would come back and say this many of them matched. So they never told us the exact number. And through a bunch of experiments, we figured out they were just doing simple rounding, right? And so they were rounding to basically 2 significant digits. So the number you could get back was always from this set here. So 20, 30, 40, up to 100, 120, 130, 140, up to 1,000, and so forth. All right? So they were sort of obfuscating, probably to protect user privacy in this set. The second thing we found is a little more subtle. So let's suppose I uploaded a list of users, so email addresses or whatever. Internally, Facebook matches that to their accounts, and they come back and report the size of that. So in my simple example here, they report 3. Now, of course, they wouldn't actually report 3, but let's just, for the example, let's just go with it, okay? So the question is, well, what should Facebook do if I include an additional record that points to one of the users I've already matched, right? So in other words, I upload your email address, and separately, I upload your phone number. Well, Facebook was smart. They're like, I'm going to tell you the number of users in this set. So they say, okay, I'm going to deduplicate this set, and ultimately I'm going to report you back 4. Seems fairly reasonable. They don't want to lie to advertisers and tell them there's 4 users when they're actually 3. Okay? But it turns out that these two features together can be abused in a number of ways. So let me show you how we did that. But to do that, I need to sort of walk you through a couple of steps. So here's the particular attack I want to start with. So let's suppose I have a list of phone numbers, and I have your email address. I want to ask, is your phone number in this list? That's the attack. Okay? So is this victim's email address correspond to one of the users who have this phone? So let me show you how we can do that. So let's suppose I take this list of phone numbers, and I simply upload it to Facebook. Now Facebook is going to come back and report to me the number who matched, just using what we talked about before. So in this example, they come back and they report 670. So I don't know exactly how many. I don't know if I uploaded 1,000 records, which 670 matched. I don't know if it was actually 672 or 668 or whatever, right? But what I can do is I can add another record. I upload that list. Facebook comes back and says 670. I add another record. And then Facebook comes back and in this case says 680. So now what do I know? Well, I know that this one right here is what I call a threshold list. Meaning whatever internal logic they're using, that's right on the rounding threshold, right before the rounding threshold. Okay? So now what I do is I take that set and I add your email address to it. I upload that. What's going to happen? Well, Facebook's going to come back and either say 670 or 680. Well, what does it mean? Well, if they say 680, that means you pushed them over the rounding threshold, meaning you weren't in this list, right? But if they come back and they say 670, that means you were already in this list, meaning your phone number is in this set. Does everyone follow this attack? It's pretty straightforward. Okay. So it seems kind of cute. You're like, okay, that's great, you know, that shouldn't be allowed. But let's get a little smarter. So let's suppose instead of asking, let's suppose I pick that target list very carefully. Suppose I ask, is your phone number in every phone number in the United States that starts with a 1? Right? If you are in that list, then your phone number starts with a 1. If you aren't, it doesn't. Repeat this for every digit, repeat this for every value, and in the end you can infer a user's entire phone numbers. Okay? It's a pretty straightforward extension of this. And so to validate that this actually worked, we attacked, we looked at users in Boston. So we, phone numbers of the form +1 617. There are 7 different values for the beyond the area code. And so each list would then contain 1 million numbers. There are 10 lists per digit, and so there's 7 digits. So in the end, we uploaded 70 lists to Facebook. Each one of them had one particular digit in common. We got 14 volunteers in Boston, and we used their email address, which they had already given to Facebook, to see if we could infer their phone number. For 11 of those 14, it worked. The phone number popped right out. For one of the 14, they had never reported a phone number to Facebook, so we weren't able to infer anything. For 2 of the 14, they actually reported multiple phone numbers to Facebook. And our initial methodology couldn't handle that. We have an extension that's in the appendix of the paper that does handle that. So ultimately, we were able to infer all of the users whose phone numbers they had reported to Facebook. We repeated the same thing in France using a couple of colleagues who were co-authors in the paper, and we were able to infer all 8 of their mobile phone numbers in France. You may be wondering about sort of what's the cost of this kind of attack. And I'll note the most expensive part by far is uploading these lists. But each one of those takes about 20 minutes to upload. It takes about a day to get ready. But that is a one-time cost. Once you've uploaded all these lists, you can use that to attack as many users as you want. And each attack takes about 20 minutes to get all the statistics and sort of do all the stuff that we talked about. So in terms of PII-based targeting, this is only one of the other attacks. There's also features based on website pixels, so pixel-based tracking. The way that works on Facebook is that actually creates an audience for you. And so we can use that to de-anonymize users who come to your website. We can get all of their phone numbers en masse. There's a few other attacks we have there. And in all of these, anybody can do this because anybody can be an advertiser. Any active Facebook user can be a victim, and there's no way they would know this had happened. There's actually no interaction with the victim, and it doesn't cost anything because all you're doing here is uploading data and getting back statistics. You're not actually running ads. So of course, we responsibly disclosed this to Facebook before we published the paper. They addressed it by simply removing statistics whenever you have PII, like a PII list that uses multiple attributes. So in other words, if I upload a PII list that only has email addresses, they'll report the statistics back. But if I have a list that has phone numbers and email addresses, they won't report anything, which does address the attack. But ultimately, it's sort of an unsatisfying solution. And so we looked a little bit about other ways that you could potentially address this. And if you recall, there are basically 2 features of the interface that Facebook had, the obfuscation and the deduplication. And if you keep trying to make the obfuscation fancier, meaning add noise or whatever, ultimately I can just take statistical samples and sort of get at the true value. So instead, what we propose is addressing the deduplication. So simply, if you're Facebook and when you go to match this set of addresses if you report the number of unique PII values that you match, not the number of unique users. Because then what that prevents me from doing is linking that this email address and this phone number actually belong to this user. Okay? There. So let me pause there and ask if there are any questions. Yeah.
So the Korlova attack. Oh, okay. The microphone right next to me. Okay, the Korlova attack didn't use a report from Facebook on the number of users that match. It merely ran the ad and see if anyone clicked on it, and
or if there was an impression.
Or if there was an impression. Sorry, yes. Right. If there was an impression, it doesn't need a click. Wouldn't something like that? It would be noisier, but again, you can run statistics. Be a way to get around that last defense you made.
Absolutely. We were only looking at the statistic reported when you upload the audience. We did not look at impression statistics, and the number of clicks and all this other stuff. That's actually, I was going to talk about that a bit later, but I'll talk about it now because it's interesting. That's actually really hard to protect because those determine how much the advertiser is billed, right? And so then you sort of get in this squishy area where do you want to overcharge, undercharge the advertiser, or so forth. It's not clear what the right thing to do there is. And so we haven't looked at that. I will also say there are other features of the platform that are also unexplored. They have this thing called Audience Insights, where you can go and see, all the demographics of your audience and so forth. There's a number of statistics in there we haven't looked at. And we also haven't looked at Google, Twitter, any of the other ones that also have similar features to see whether they're particularly vulnerable.
Great. Of course, that attack would then cost money.
Correct. Yeah, exactly. That's why we focus on this one where it's completely free. Right. Push on the bottom. Turn on the bottom.
It also makes sense for Facebook to rate limit the number of queries you can make as an advertiser, and also maybe adding some more barriers. For example, you have to spend a certain amount of money to make certain number of calls and so forth.
Yeah, so there are a number of things they can do there to raise the difficulty. Ultimately, none of those will prevent the attack, especially in the world of civil attacks where I can create fake accounts or compromised accounts, and every single one of those can be used to create an advertiser account. So we're pushing towards this, more guarantees instead of simply raising the barrier. But they, in our discussions with them, they are thinking along those lines of other ways they could just simply raise the difficulty of doing the attack. Okay, so the last thing I want to talk about is somewhat, unexpectedly, an opportunity. And so what I've sort of probably scared you a little bit in terms of sort of this ecosystem and all the things that exist, but I'm going to argue actually there may be some potential to help users using this system. So what I want to talk about here is data aggregators. So these are companies that are like Acxiom, Datalogix, TransUnion, Experian, but their business model is buying and selling data on people. And so they collect data from public records, voter records, criminal records, as well as partnerships with other companies, aggregate the data, clean it, link it, and then we'll go and resell that data to third parties, often to things like banks when they make a decision about whether or not you should get a loan, marketers, political parties, and so forth. Yeah?
Are these the same or different people than what are called data brokers?
Basically the same. I'm just using a broader term, data aggregators, because I actually argue Facebook is one of these, and you wouldn't. Okay. Data brokers are ones who sell the data, and data aggregators are ones who just simply collect it. But, exactly. So you're probably wondering, what kind of data do these companies have? And it's actually quite challenging to answer that, because generally, if you want to get data from them, it's probably under NDA or so forth. They don't really want you to know. But if you dig around on Google a little bit, you'll run across this slide, which I did not make. This came from Acxiom, one of the largest companies here. It's sort of hard to read because it's kind of a terrible slide. But there's lots of scary things there, like individual wealth indicators, travel, dwelling, household information, and so forth. If you dig a bit further on Google, you'll find something like this called the Consumer Data Products Catalog. I don't think people are really supposed to have this, but somebody put it on Google, so go them. And if you look through this, all it is pages and pages of record types. So different kinds of information, different attributes, if you will, that you can buy on people. And there are literally like 50 pages of this. And there are things in there like, the basic ones like demographics, home loan information, whether you're predisposed to gambling, whether you're divorced, if you're diabetic, a smoker, and they have these sort of categories like new teen driver and empty nester and so forth. So there's lots of very interesting stuff here. And so you're probably wondering, okay, well, especially for those of you who live in the United States, what data do they have about me? Well, they have a website called aboutthedata.com, run by Axiom, where they purport to reveal all of the information they have about you. And so I ran this for myself and my wife. And what you see is that when you go there, they have 6 different groups of kinds of data, so demographics, housing, vehicle, income, purchase data, and interests, where they have some small number of attributes in there, between like 1 and 30. And what I've shown here is the number of attributes they have for me and my wife, and whether or not those attributes are correct. And what you'll see is that, first off, this is much, much smaller than the set I've shown you like on the previous slide, where they have thousands of types of record types. And they're, the kind of coverage they have here is sort of odd. Like my wife and I own the same house, but all of that falls under me and nothing falls under her, for reasons that are entirely unclear. But anyway, the point is that the transparency mechanism they have is rather limited. Okay? The other thing they have that I thought was super interesting is I have like a number of blockers and whatever on my web browser. She does not. And so they have tons of information on her purchase data, but they have almost none on me, which I found was interesting. So use your ad blockers. That's the takeaway. So you might be wondering, okay, well, what rights do I have to this kind of data? And so in the US, outside of very particular areas like credit reports, you basically have no rights. You don't have the right to get your data. You can't go to Axiom and say, give me everything. Unlike Europe where you have GDPR. You can't check the correctness. You can't make them delete anything. You can't ask them where it came from. And you can't even know who has bought data on you. Right? You basically have no rights to this data. The Federal Trade Commission a couple of years ago released a report basically disclosing all of this and calling for a sort of centralized transparency websites. You can read the report online. But the point is that even today, there just isn't much transparency in this ecosystem. So the question is, can we somehow use the targeted advertising systems out there in some way to maybe reveal something? And so if we look at Facebook, one of the things we found was really interesting is Facebook partners with a number of these companies. And in particular, what that means is they're joining their database. So Facebook has its database, Axiom has its database, they've joined it, and they've imported attributes from Axiom and other companies into the Facebook advertising platform. To Facebook's credit, they reveal this on the advertising side. So if you go to place an ad on Facebook, you'll see some of the attributes here are tagged with a source. This says partner category based on information provided by Oracle Data Cloud, which used to be known as Datalogix. Okay? So it actually tells us something about where these attributes are coming from.
So Facebook has said recently that they're going to stop doing
Yes.
this. Have you seen any evidence of that?
They pushed back the deadline. So my understanding is you can't run any new ads with these starting sometime in early August. Originally that was supposed to be July. And then starting October 1st, I think they say they're going to be completely gone from the platform. So we'll see.
Do your research quick.
Yeah, exactly. If you want to study this, like, do it now. So what we did though is we crawled all of this and we looked at from 8 different countries what's that. Oh, sorry.
Just one thing that should be emphasized is both in their public statements as well as Zuckerberg's testimony to Congress, they repeatedly say that all the data that Facebook collects has been given to them voluntarily by users, which is absolutely untrue. If you even just read Facebook's privacy policy, it discloses all of the data aggregators that they work with.
Yep. Yeah, and we've done some studies looking at the transparency mechanism. So if you ever done the ad preferences thing in Facebook that'll show you your attributes, hilariously, they never reveal any of these. So there's, as I'll show you in a minute, there's a ton of attributes. They will never tell you which ones come from data brokers, even though they let advertisers target you with those attributes. So, food for thought. So we crawled these from 8 different countries because the set of attributes that exist vary across country. Let me just finish this real quick. And so this table shows you the number of attributes from different sources, from different advertiser countries around the world. You'll see Facebook infers 614 in every country, and then the number varies where the total is shown here. And for example, in the US, that's where the number 1100 comes from. And then it goes down to, there's some countries that have just a few.
Yeah, just a simple question for Axiom. So do you have to authentify when you use the service about which was for Axiom, which where you ask the data that they have?
Yes.
What do you have to authentify?
Oh, yeah,
or
you
what
have
do you
to
have
give your social security number, which is awesome. So.
So you have to send your social security
Yeah.
number in order to get. Okay.
To get, I mean,
So
I
if you
guess
know the
that's good.
social
I don't know, there
security
you go.
number of people, you can get a lot of data just by using
no,
it.
no. That's certainly, you cannot do that. Or you're not supposed to be able to do that. I haven't looked at that. Yeah. They're supposed to ideally only reveal it to you. And I think you provide your social security number as, you know, as well as other identifiers. Yeah, exactly. Like, I'm not saying it's a good idea.
For all your employees, basically.
What's that?
So you can do it for all your
Correct.
employees.
Yeah.
But it doesn't tell you the data. Oh, no, it did tell you.
It tells you your attributes. So I don't think it reveals like, I'll have to look and see. It reveals like things like you purchased this kind of product or you own a house worth between $500,000 and $1 million or whatever. So it's sort of coarse-grained attributes. It doesn't actually tell you very fine-grained things. Okay. So if we look at these attributes, if we dig a bit deeper to try to understand what's the difference between data broker attributes and the Facebook attributes, what we see is the Facebook ones are divided into 3 categories: behaviors, demographics, and interests. And most of these appear to be ones where you can imagine Facebook could infer them. Things like digital activities, so like where are you browsing online, life events, so like when you get married, most people post that to Facebook, so they can figure that out. When you have a kid, you post that to Facebook, they can figure that out. Education levels entirely self-reported by users. And then interests come from sort of the pages you like. So these are ones that you can imagine Facebook would be able to infer. If you look at the data broker provided attributes, those are ones that you can imagine would be harder for Facebook to infer. So those include things like your purchase behavior, because remember they're partnering with Oracle Data Cloud. Oracle Data Cloud bought or used to be Datalogix. They were the company that runs loyalty cards. So when you go to the supermarket and scan your card, so they know exactly what you bought. Other things like residential profile, like what kind of house you own, financial information about your net worth and what you invest in, and all what kind of car you own and so forth. Okay, and so the question is, can we somehow increase the transparency using the targeted advertising system? And so what we're going to do in this idea is target users with attributes, but reveal to them what attributes they have in the ad itself. Right? Sort of use the advertising system against itself, in a sense. So in other words, we're running ads, targeting users who opt in, and we have an ad running for every single one of the 1,100 different attributes. And so if you're one of our users, you will actually get ads from us, but inside the ad, it will reveal what attributes you have. Now, we don't see that because we just simply see statistics on the number of impressions we get. We don't know who actually saw it. But what it's doing is it's revealing to users that if you receive this ad, you have this particular attribute. Right? So it's a form of transparency service. And so as an example, we ran this for me. I sort of made this very small so you can't read it. These are my Facebook attributes. And then these are the ones that came in from Axiom, and these are the ones that came in from Datalogix. And they are more detailed than the ones that I got through the aboutthedata.com website. So we're still, we've gone through IRB for this and so forth. We're still at the point where we're testing it, but if you are interested in, participating, email me and I'll let you know when it's sort of public. Not this one. Let me change that. Okay, so I want to finish by just talking briefly about what I see sort of the broader research agenda here, and then I'm happy to take questions, and then I'll let us all go to lunch. So basically I see sort of 3 high-level themes in terms of, if you're interested in this space, what I see as the open challenges. The first is auditing. So we've looked at one service, Facebook, and we've looked at just a couple of the features that they offer. There are many other services that offer similar features and different features. We haven't looked at those, so we obviously need ways to better understand these and scale up the kinds of studies that we're doing. And so there's other features like tracking pixels, mobile advertiser IDs, audience insights, billing information, and so forth that we haven't even taken a look at. The second is looking at sort of developing mechanisms to allow for privacy-preserving statistics. So some of our privacy-based work abused the way that they were reporting statistics to leak information. So you need some mechanism to release these statistics to advertisers, but that provably do not leak data. And this, so you sort of think differential privacy kind of sounds like the right solution here. It may be. I'm not enough of an expert to know. I will say there's lots of different mechanisms to release statistics, so it's challenging to implement, and also it's hard to limit the number of queries because advertiser accounts are basically free. So you can go create many accounts, and it's not clear what would happen if you expend the privacy budget, then Facebook can't report any advertising statistics to anyone, which seems sort of bad. And finally, I think there's a lot of opportunities here to work with lawmakers and regulators. As technologists, we sort of understand these systems. Many of the lawmakers and regulators don't quite understand them. So I think, working with the Federal Trade Commission in the U.S., similar organizations in Europe, there are a number of opportunities here. Especially to remember that these services, like there's no verification. Anybody can sign up as an account and use these services. So with that, I'm going to stop exactly at an hour. I'll say all of this work is in collaboration with my colleagues at Northeastern, MPI, ACBS, CNRS, and Eurocom. And I'd like to thank our funders, the International Science Foundation, as well as the Data Transparency Lab, which is based here in Barcelona. So thank you very much.
Okay, so we have about 30 minutes for Q&A now. Lunch will be next at 1 o'clock. This room will be locked, by the way, during lunch. So anyone that wants to leave stuff, this room will be locked. So if you want your stuff during lunch, don't leave it in here, but don't worry about stuff wandering off. The next session will start at 2:30. If you want to leave during the Q&A, please leave quietly so that the rest of us can do it. And try and raise your hand and wait for a mic while before asking questions.
So again, about the new rules with the data brokers, and it seems like there's nothing necessarily, Facebook's basically just cutting themselves out of the loop. A data broker can still sell custom audiences to an advertiser that can then use them on Facebook, right?
Yeah, so you can still use the PII-based targeting. So they're basically, what Facebook's doing today is they're simply matching the database and making those attributes available to all advertisers without having to go through the data broker. But as you point out, you can go to the data broker yourself, get this information, and then go upload email addresses, phone numbers, whatever you got, and still target exactly that set of users.
Hi, I have a somewhat adjacent question in terms of the research agenda. Could you talk about some of the logistical difficulties that come with doing platform research? For example, like you're paying the platform to study the platform to fix the platform's problems, sorts of things.
Yeah, so there's a number of interesting things. I mean, there's sort of technical challenges with doing this that are not super hard. You're sort of looking at the platform, looking at how your browser interacts with it and so forth, but that's fairly standard. Some of the more interesting challenges are, one, you're violating terms of service to do a lot of this work. I have some questions or some answers I will give you offline about my opinions on that. But that's just sort of like, that's table stakes in terms of doing this kind of research. The other challenges, yeah, I don't know. In terms of it's basically just measurement-based work. Like you're trying to reverse engineer the platform, and so yeah, I don't know. I can't think of any other challenges that are unique to this that wouldn't exist in studying other systems. Like we've done other studies looking at Amazon and Uber and so forth, and a lot of those challenges sort of come into play here as well. But in terms of you asked about paying the platform to study it.
Like if you actually have to serve ads, for example.
Okay. So there's a lot of human subjects protection stuff that absolutely you should go through. So when we were doing the studies, we only looked at our users who are on the papers, like the authors, or we made sure to never reveal any PII to Facebook that Facebook didn't already have. So we weren't sort of targeting users and giving Facebook their PII. So you need to be careful with that sort of thing when you run ads, and also interfering. Like when you're collecting ads, you need to be very careful not to cause ad fraud. In other words, so there's studies where people have looked at let me just go collect a bunch of Facebook ads, and they sort of hit Facebook a lot of times, and that's actually costing advertisers money. So you don't want to do that kind of thing. So we, in our studies, for example, when we're running ads, we're not costing any other advertiser money. We're actually paying them to paying Facebook to show the ads. So those are sort of a number of the different considerations that come into play.
Thank you for your talk. My question was about the focus on concealing, finding out about discrimination by looking at the outcomes. I think there are some recent papers that show that you can actually practice disparate treatment and conceal it in the outcomes. So I'm thinking if fairness gerrymandering by Michael Kearns, but also the work on Sam Corbett Davies and Sherrod Gould, where they have a really beautiful example of police stopping Black or African American drivers more often, and then by virtue of the distribution of the target variable being different, that you can conceal in the disparate outcome that this has been happening. So given these limitations, on the one hand, I wonder if there should be a stronger statement about discrimination and how these interfaces can be used, and could this also be suggestive of arms race, where those who want to practice disparate impact use these techniques to conceal the fact that they're doing this in outcomes.
That's interesting. I wasn't familiar with the work, but certainly, anytime if you could obscure it in that way, that whatever proposal we have would potentially fall under that. I will say that, I think looking at outcomes is at least moving in the right direction versus looking at process. I think there have been similar studies on I'm familiar with one from the New York police where they were looking at the stop and frisk, and they had this very particular set of steps they walk through, and that was sort of if you start banning certain processes, there are other ways to get around it even more easily. So we think looking at outcomes is probably a better way to do it, but there may be certain caveats like the ones you're talking about. So it'd be interesting to look at, but I'm not an expert. Yes.
Yeah, how are you exactly proposing to match the attribute and the ad? As you were saying, when users will see the ad, they will know what attributes they have. But is it always a one-to-one mapping from an attribute and ad? And also, do you propose the users know all the list, which attribute corresponds to which ad, and then manage themselves all these things?
So that's a great question. Essentially what he's asking about is how do we reveal to users what particular attribute they have? And so what we're doing, remember, we're running, say, 500 or 1,000 different ads, and each one targets exactly one attribute. So what that means is if the advertising system works as it's advertised, and if you receive that ad, then you know you have that attribute. Or at least as far as Facebook is concerned, you have that attribute, right? So there are basically two ways that you can do that. The first way is you can literally put in the ad text or in the image the name of the attribute. So in other words, the user just sees the ad, they immediately know what attribute they have. Now, that may violate the advertising terms of some platforms. Some say you cannot do that because they're trying to prevent users from having, say, creepy ads that say no things about them. And so in that case, that doesn't really, it's not really applicable to what we're trying to do, because these are all cases where the users have opted in to receive our ads and they want to know their attributes. And so if that's a problem, you could obfuscate the text in the ad and say, give an attribute number. You could obfuscate it using steganography or whatever you want, pick your favorite thing. But then give users a mechanism to decode whatever ad they see and figure out what attribute they actually have. So we're still playing around with exactly how to run that, but thus far we haven't run into any issues where the platform says you can't run this particular ad.
Thank you for the talk. So advertisers can basically profile users and just target them. But what if contract Facebook or any other company that runs advertising? And so,
Sorry, it's cutting in and out.
okay. I don't know. That's okay. So what if the Facebook or other companies can profile the advertisers so that they cannot so many queries and the way you did?
So essentially you're talking about rate limiting or these sorts of things?
Or yeah, basically. So if Facebook just made a profile of your queries on the system, it would have been very easy to recognize that you're probably trying to extract information from your queries, right?
Yes and no. So I think the way we did it, absolutely. Like uploading every phone number in the U.S. that starts with a 1 is kind of sketchy, right? But if we were sort of ever so slightly smarter, we could encode this information using other encodings, upload it in more lists and so forth. So I think, it would raise the bar, but I think ultimately, it's not going to provide you any guarantees, if that makes sense. So we could have, uploaded smaller lists or used multiple accounts or so forth. That would have, made it much harder for Facebook to try to figure out what exactly we were doing.
So in your de-anonymization attack, let's say Facebook prevents the application, it doesn't employ it. Can I still employ auxiliary information to attack the system? So I have, let's say, a customer database, but it's incomplete with missing information. I want to find out that missing information, exploiting this advertising system.
It depends. Like, again, we've only looked narrowly at the size statistics that are reported back from custom audiences. So when you upload, they come back and give a statistic. And our proposal would prevent that particular statistic from leaking whether or not two pieces of PII are actually linked together. Like that's sort of the narrow scope of what we're proposing. There may be many other ways that you could use external information in like impression statistics or a Korolova style attack, or you could, upload lists of phone numbers of, users who don't exist or users who are, are all asleep. And then if you get one impression, it came from your target user, not these other users. So I think there are a number of games you could play in that space if you wanted to try to leak additional information. We haven't looked at protecting those, and our particular proposal would not protect against those.
So several of the stories you told followed a pattern of the attack works perfectly fine, the attack is disclosed, a prevention mechanism is deployed. Did you find any cases where an attack against user privacy had been preemptively thought of and prevented by an ad platform at all? And what does that say about their incentives and behavior?
That's a good question. I would say, they do a number of things to ostensibly protect privacy. So, for example, the rounding of the number of users who are in the thing. I don't know if that's a result of an attack, but I think they probably did that to protect privacy. Some of the other platforms have higher thresholds, so like Google has at least 1,000 and so forth. It's not clear to me, how much that buys you, but it's a little bit more than Facebook. I will say that they were pretty responsive when we did responsibly disclose this. Eventually, once we got in front of the right people, so they have fixed that. I think ultimately a lot of this is a trade-off between advertiser utility and user privacy. That the more features the more privacy protecting features you give to the user, it's going to impact advertiser utility in some way. Like their statistics are going to be more off, or their billing is going to be more off, or so forth. And so Facebook, I think, is trying to decide where does it, how does it judge this trade-off? So I'll give you one example where we found an attack where we could infer whether or not a phone number or an email address corresponded to an active Facebook account. It wouldn't tell us who it was or anything else, but is this targetable, if that makes sense? And so we disclosed that as well, and Facebook came back and said that's not considered an attack. So in other words, they said that that's out of the scope in the sense, and they're okay with that existing. So that's a case where, to fix that attack, I think they felt it would have been too cumbersome, and they felt the privacy implications of that were not significant enough to warrant actually addressing it. So I don't know if that fully answers your question, but they are concerned with this sort of thing, but I think ultimately from their view it's a trade-off between how much advertiser utility versus user privacy to play. If that makes sense.
I have a question here in the back. I wanted to actually follow up a bit on that trade-off. In a way, it's like I think calling these things advertisers or advertisements maybe is a little bit too narrow of a frame for something that is actually like it's become the mode of effective communication in the current online communication ecosystem, and for NGOs, for political parties, for all sorts of types of communication, these are the most effective, have become the most effective means. So there's actually a lot of ways in which there's an incentive now for even for entities that are not necessarily so happy with this type of data processing that is happening to be sucked into this and to use some of those ad targeting, communication targeting techniques. That presents actually a much bigger question about like how to also do these trade-offs. And there's a bit of a danger, of course, that if the platforms become much more restrictive and they start to do all sorts of reviewing on the communications that they allow, or the sources, the types of entities that they allow to use these tools, that could be quite a big freedom of expression issue. Have you seen any responses by the ad platforms that suggest that there could be a kind of a narrowing of the possibility to communicate for entities that actually should be allowed to use these platforms also effectively?
So that's a very relevant question. I don't know if you saw the interview by Mark Zuckerberg the other day where he commented on who he feels should be able to use the platform. I think that's much broader than advertising, where we look simply at how are the advertising system protecting user data and could they be revealing information. I will say that there is a new opportunity to look at who is running ads using the political advertising transparency mechanism. So Facebook has two mechanisms they've introduced recently that are quite interesting. Damon's been doing some work looking at that, where first of all, they reveal all ads that a given page is running. So you can see all of the ads they have running now. You can also reveal for political targeted ads, they have an archive where you can go and actually see impression statistics and targeting statistics, meaning how many men and how many women and what states and so forth they're targeting. So that's something where they're treating ads of one class differently than they're treating other ads. I'm not going to comment on whether I think that's a good thing or a bad thing, but it's certainly open for debate.
So they're more like comments than questions, although they may provoke. The first one is, this is following up on something you said. The U.S., we've always had an ex post facto way of handling privacy issues. What you're describing is talking about is really looking at outcomes. So you had a question much earlier, I think, from Ian about controlling the ads, but of course what you really want to look at is outcomes. And I think if you think about talking with FTC and so on, you really want to start using the verbiage of outcome, because I think that's, the ad is a mechanism, but the outcome is what's really important. The other is, when you made the comment just now about Facebook said, oh, it's not really a problem about phone number or email address, my immediate response was, well, my God, I'm not on Facebook. So that means that somebody else could find that out and therefore perhaps put up a Susan Landau. And so that brings up a very different issue, which is, I think it would be extremely useful for you to start talking to the national security folks, if you haven't been already.
We've just started that, but yeah, we're reaching out to folks, the FTC and a few others as well.
No, I'm talking to national security folks.
Maybe
So
you and I can connect.
Yeah, I was just going to say, let's talk later.
Be happy to.
Given that the discriminatory advertising is not going to go away anytime soon, and in this talk, it seems like you're focusing more on the advertisers and the platform, Facebook. I would love to hear your thoughts on what kind of strategies can users adopt to potentially avert discriminatory advertising. So let's say I'm assuming like someone is trying to do discriminatory advertising to me on the basis of, let's say, religion or sexual orientation or whatnot. So do you think there are some strategies that users can adopt to mitigate the effect of these?
So I would say, it's quite challenging as a user to see because the ads are ultimately personalized, right? So you're only going to see the ads. So there's basically two questions you could ask. One is, of the set of ads am I seeing, are those discriminatory targeting my attributes? Or for the set of ads I'm not seeing, could those be excluding me in some way, right? And so both of those are very hard to answer unless you have an underlying distribution of all of the ads to see, what ads am I missing, or what ads do I get more commonly than other people. So there's basically two ways I could see of addressing that. One is by, you can get a little bit of insight from the ad explanations. So again, you right click on the ad, why am I seeing this ad? It's very limited, they only give up to one attribute, even if the advertiser used multiple ones. And they tend to give only the most prevalent attribute, not the one that's the most niche. So it's not going to reveal a ton, but it will say things about age and gender and so forth. So perhaps you could get some insight from there. The other database you could look at is this political one I was talking about, because what's nice about that is they actually have impression statistics. So you can at least get an idea of what's the underlying ad distribution to do that and then compare that. We do have a project in collaboration with the folks at MPI called Ad Analyst. You can Google it and you'll find it. And essentially what it does is it's a browser extension that collects all of the ads you see, all of their explanations, reports them in a anonymous way. And then we have aggregate statistics on all of the ads that users are seeing. So it's sort of like a crowdsourced ad analysis kind of thing. And so that may give you some information about what ads are other people seeing. And then you can look at, like, for the advertisers who targeted me, what are the other ads that other users saw from that same advertiser, to see if they saw different ads and maybe they were targeted differently. So ultimately, it's really an open question, but there's some steps you can take to get some idea of how your ads are different than other people's ads. Damon is one over.
Thanks, Alan, for this talk and this work. And I think it's a great example of how sometimes some of your product features leak some information that you didn't intend to, right? And do you think there is like anything you can learn from this for the process of developing products and features that people could have thought of before? Or do you think the only way is kind of building what you want to build, like with utility in mind, and then afterwards do some kind of privacy risk analysis? Or do you think there's also something people can maybe learn from this for, like, the process of building products and software?
Yeah, I mean, so I don't know what happens inside these companies, so take everything I'm about to say with a grain of salt. But from studying how these systems are developed and how they how they're implemented, it seems that each additional feature was implemented sort of in isolation, and they sort of look at, okay, how can I protect this feature? Well, I'll round it and do this and this, and then I'll sort of release that. But the leaks that we found were all sort of these, combining different features together, and each one reveals a certain information, and as a result, you can leak information. So I think, again, I'm not an expert here, but I think what you need is some sort of comprehensive way of, whenever I'm going to release statistics, I use some particular mechanism that provides me guarantees. So, like, for example, some sort of differential privacy-based thing, or maybe something else, or whatever, whatever. I don't know exactly what the solution would look like. But I think that the risk is that different features could be combined together to leak information when each individual one is not leaking information. And that's exactly what we saw in our attacks.
For the political ad archive, I mean, maybe this is a question for Damon, but do you know if it's, do you know how broadly they're considering political ads? Is it, political action committees and so on, or is it just, parties and candidates?
So Damon will have to correct me if I'm wrong, but my understanding is that the advertiser can opt in and say, my ad is political, and then it shows up in the archive, and they're doing some sort of machine learning, something looking at the content of the ad, and they will flag ads that were not self-flagged by the advertiser, and then put them into the archive as well.
Facebook has a definition of what a political ad or political content looks like. So they have, I think, 12 issues. They also do like political issues, so they've defined 12 political issues. I think one of the 12 is values, and so it's fairly broad in that sense of the word and things like that. And so our analysis of it, we've seen like people selling T-shirts, political T-shirts, we put into the political ad kind of thing. So it seems like they're taking the approach of perhaps more false positives.
I will say this is one of the few times you get insight into the targeting specs and the advertising inventory, which is generally very, very hard to measure without, conducting ad fraud, basically. So it's a very interesting data set. I think they just opened it up a month or two ago, something like that. Like it's.
Yeah, I think the end of May.
End of May. So it's fairly recent. Mm-hmm.
Well, keep in mind it's limited to the U.S., so there's very few European ads. Okay, with that, we'll go ahead and start lunch a tiny bit early. Let's thank Alan again for a wonderful talk. And again, this room will be locked, and the next session will be at 2:30 on HCI and policy. Should be very interesting.
Exactly. Ironically.
minutes left. Okay. There. Should be all readable, nice and big. Done. All right.
Thank you.